You're wrong.
Well, how can you prove that?
By going to Antarctica.
That doesn't prove
Yeah, it
that
does.
He doesn't
I
believe that proves that the shape of the
right.
ground has to make the same as, so that wouldn't prove anything for him,
It
Brenda.
doesn't
You
matter
have
what
to
he
have a
believes.
specific presupposition in mind when you go down there in order to believe something like that.
It doesn't matter what
Right.
you believe. It matters what's true. It doesn't matter what you believe.
So let me ask you something, Brenda. If I go down there and I see a 24-hour sun circling above me and never setting, are you going to say to me, how are you still a flat earther?
Yeah.
And what if I said because what the luminaries, the sun, the moon, the stars do in the heavens don't dictate the surface that we walk around on? Do you just say nuh-uh?
You would be wrong. You're just
But you're
mistaken. You're just
oh,
mistaken about what the case is.
so
You've made it.
you
You
know
made a mistake.
personally what this realm is, what the diameter, the parameters, how it's made, where the limits are, where the boundaries of this place are.
No. The point is that it falsifies the flat Earth.
Well, have you realized that I don't buy into the flat Earth model or the globe Earth model? I think they're two false dichotomies. It's not reality.
Yeah, Brenda doesn't share our beliefs, so we're wrong.
No, it. You don't share the facts. That's what you don't share.
You don't even know what a fact is, Brenda.
Yeah, I do. Right. So the point is, if the Earth is flat and the sun is over the equator, it can't be over Antarctica.
Are facts
Okay, Brenda,
preference based?
if the Earth is flat, explain mountains.
Hey, is it
No,
are facts based off preference?
no,
No fact.
I'll respond in this way because really the argument is Brenda's saying, I know what this realm is and I can explain it. And I say, I don't think you can know all the,
I didn't say
parameters.
that.
Well, I
I didn't
mean,
say that to you.
you're saying that you know that if a 24-hour sun is present in Antarctica, that means we're on a spinning ball Earth.
No, I didn't say that. I said
So what
that
does it mean? What does a 24-hour sun in Antarctica mean to you?
it means that the Earth can't be flat.
And if there's a kaleidoscopic effect or a personal atmospheric dome, reflections, refractions, that things that we probably can't even comprehend in place in this realm, this created realm, then does that mean anything to you, or does it just all
No,
sound like garbage?
yeah, that's word salad.
All
What
right.
is
It's a
what is a
kaleidoscope in the
kaleidoscope?
sky. The
What is
Beatles told you. The Beatles already told you.
They did. They
what is a
did.
kaleidoscope? What does a kaleidoscope have to do with whether the sun is over the equator or it's over Antarctica? What does that have to do
It's
with
an
each other?
analogy, Brenda,
What's the analogy?
Give me a
that the
second. I'm going
sky
to.
seems to work like a kaleidoscope would.
It
A
does work like a
kaleidoscope is just a
kaleidoscope, yeah.
tube with a kaleidoscope is a tube with mirrors,
The
right?
sky works like a kaleidoscope in both models.
Uh, how so? No, it doesn't. A kaleidoscope is a
What
tube.
percent of the sky do you see at nighttime?
A kaleidoscope is a tube with
What
Say
mirrors.
50,
percent of the
Brenda, say
sky do
50.
you see at nighttime?
I don't know. Part of it.
Okay, how much would you say
I don't know.
of the night sky? Would you say
I don't know.
50%?
I don't know.
No, you
3.
don't know? Okay.
No, I
All
don't
right.
know.
How much do you occupy in space? What percentage of Earth do you occupy in space?
Oh, if I'm standing about 1 square foot,
There you go. There's your kaleidoscope. Thank you.
that's not a kaleidoscope. A kaleidoscope is a tube with mirrors. What are you talking about?
You're done.
No, a kaleidoscope is a tube and you have an eyepiece and mirrors, right?
All right, what do you
That's
get
not
when you
standing on the
smash?
ground. That's not standing on the ground.
What do you get when you smash a telescope into a microscope?
right? So the point is that the final
Kaleidoscope.
experiment falsified
It's a
flat
Is
Earth.
it collide?
kaleidoscope.
That was pretty good,
Is
Jeremy.
it collide?
I like
Yeah.
that.
The sky's a kaleidoscope. You just
I
admit
figured
it. You say
everyone
you
would have
see a
got
lot
it.
more. You see a lot more of the
Nah,
sky
bro.
than the space you occupy. Therefore, it works like a kaleidoscope. That's the effect
I,
of a kaleidoscope.
I was so far off, dude. I was thinking everything but that.
That's a kaleidoscopic effect. What are you talking about?
Where are the mirrors?
That's a good question. They might
Yeah.
be in your mind. How can you prove it? How can you prove they're not?
Shout
Look,
Joe a
one of these
text.
things has got to
He
be
might
curving.
he might come in. He's really been looking into this lately. If you'll give him room to speak.
So Ron Boston Bear, where is the South Pole?
That's assuming there
Now,
is a South Pole.
Well, we observe it. So where is it?
And I haven't been there.
Yeah, but we observe it. So where is it?
Dude, the crazy
Where
part is to get there too. Like,
You
say you want
observe
to go to
the
the South Pole, like
Sigma
Where's the South Pole?
directly underneath the
hang on,
stars.
hang on. Sigma Octantis is not the South Pole.
Neither is, and the Polaris is not the North Pole either, is it?
Thank
I
you,
thought that's
Brenda.
which
Very
North
good.
Pole are you talking about then? Which one? I thought you were
They're
talking
right
about the
next.
one in the sky, dude, weren't you?
The
There's
Polaris
no
is
pole
not.
guy.
The
yeah, it
Polaris
must
is
be the
not.
one.
Polaris is not on the axis directly, and neither is Sigma Octantis. But they're close.
You said that we observe it.
Yeah.
Who's observing the South Pole?
Anytime you
Nope.
take a long exposure, right, you can see the circles. The center is the pole.
So it isn't. It is in the sky now.
So the center is in the pole. Is the pole, right?
You're bananas.
When you
Why are you
see
saying right at the end like a question? Fucking
right a long exposure, you see the circles. The pole is in the center, right?
No, there's nothing in the center of Sigma Octantis. Nothing. Zero. It's black. Fucking idiot.
Yeah. That's the center of that's the poles. That's the center of the pole. That's the pole star.
That black spot is the pole. That
Yeah,
empty space
yeah,
is the pole. You're a fucking
yeah.
retard, Brenda.
Hey, let's not do
All
that.
right,
Rob,
let's
stop
slow
calling
down with the
names,
name
dude.
calling.
Yeah,
Yeah,
that's what
Jesus
it is,
Christ.
right? There doesn't have
Yeah,
to
the
be a
truth
star
hurts.
there.
Sorry, guys.
It's
Look,
the
man, if you're going to
center.
insult someone, at least be funny. Okay,
It's the center.
you can get
There
I'm
doesn't
funny.
not
have.
trying to be funny. She's
I know
being
that's the problem.
Well,
she's being intentionally held back because she thinks that the black spot in the sky is a pole.
yeah,
Rob, your
it's the
mic
center
sucks,
of
dude.
rotation. It's the center
Rob.
of rotation. It's the
Like, we went
pole.
through this and took years to get you with a. I thought you had a good mic, man.
No, dude, his mic is fine. He just keeps blowing it out by yelling into it, thinking he needs to.
Well, no, because I'm partially going deaf, and I'll try to keep my voice down. Sorry, Jeremy.
Right. So there doesn't have to be anything there for it to be the center of rotation.
So not a pole then.
Yeah, that's what we call it.
So like it's just colloquial pole. It's not
Yeah,
actually a pole. You just
no, it is.
arbitrarily assign a location to this area.
It's not arbitrary. It's the center of the circle. Right?
Hey, Brenda,
I mean, Rob,
I hollered at Joe. So whenever you're ready, Joe Hanvey's here to talk about, anything you want with the Sigma Obtantis and um, the circling sun in Antarctica, the kaleidoscopic sky. He's been looking into it. Just whenever you're ready.
I'll be right back.
Yeah, y'all can carry on. Thanks, Joe, for popping in.
Yeah, no problem, bud.
Hey, so
Nice to
What
have
up,
you here, Joe.
Joe?
If there's anything that you'd like to just give us freely, that would be great. Thanks, Joe Hanvey.
I don't mean to be like insulting or anything, but like, who is Joe Hamby?
You don't know Joe Hanvey?
I don't know Hamby.
Oh my god.
I'll do the introductions. He is the gentleman that is sort of coming up with a reasonable sort of was a model using actual materials. So, and he's putting it on an AE map essentially. If
Oh,
anyone
Is
else
there
wants to do better than that,
so
is
not
there
a
a
computer.
website?
Let's hear
Mm.
Joe. I'm sure Joe can introduce himself. What up, Joe?
What's up, everybody? Yeah,
Hi,
I
Joe.
mean, I'll start with, to be clear, like, yes, I try to model the sky system. However, I don't make any specific claims as to what the lights in the sky are or that this is exactly how it works. I'm only trying to give proof of concept that these things can work inside of a biblical cosmological worldview. But that being said, I can't model a lot of the things in the sky, and it all seems to fit scientifically with optics and many other sciences as well. So uh, I guess
That's awesome,
that's
man.
about as
That's
simple as I can put it.
Joe you guys are greeting is
What
muted.
is it? What does it mean to fit scientifically? Did you do an experiment?
Well, you
Then it's
can't
real simple.
you
The map
can't
is not the territory.
you can't really experiment with the sky. We can apply the scientific method to where we make observation, we make some assumptions based off of that observation. We then develop a hypothesis. We test that hypothesis through either physical demonstration, modeling, or the such. We assess the results of that,
Yeah,
and then
yeah,
we formulate a theory. So that's what I've
yeah,
done.
yeah. That's called science. What was your hypothesis?
My hypothesis is that we live in a topographically level, enclosed universe. So the plane of Earth is a topographical level plane that is enclosed in a universe sky system that takes the shape of possibly a dome.
So how did you test for that?
Hey, Joe, do you have a YouTube channel or like a website?
Yeah, he does. Yeah, he
I
does.
just dropped it in the chat right now. You can grab it.
Yeah, he's well
Nice.
known.
Thank you.
He's well known in the community, right? So science is you form a hypothesis and then you test it. What was your test to test whether the Earth is a biblical topographical plane?
Well, I tested the biblical model by getting a hemispherical dome, creating a level plane within that dome, and then projecting light sources into it.
Right. So what was your prediction?
That I would be able to, if that is the kind of setup that we live in, that I could model things that we see in the sky. And I've been able to model a reason for the 24-hour sun, for the southern star trails, the northern star trails, the equatorial trails, all of which I can get long exposures in the physical model that match what we do in reality with long exposures. It shows both celestial poles that you're talking about. So there is a southern celestial pole in the sky. If you want to call it a pole, it's just an area in the sky that we see relevant, apparent to the observer. The north is also, if you want to call it a celestial pole, it's a central point in the sky that we observe relevant to the observer or, you know,
I'm really interested. I'm really interested in where the South Pole is in your model.
it's an apparent position relative to the observer.
Yeah,
Maybe
but
180
where is it?
degrees to the
Where
North
is it?
Pole.
You'd have to give a time and place for that. You know that, right?
No, on his model doesn't have a clock. I don't. There's no need for it to have a clock. That's not necessary to test it, right?
It's
But
in.
where on the model is the South Pole?
It would be looking up towards the southern part of the sky in the model.
What?
On
It
an
would.
AE map, though, like different southern locations don't have south is in a different direction for them, right?
You guys
Right.
are
So
switching the souths you're talking about. Are you the south celestial pole and then the south like magnetic or something you're talking about, the one on Earth? Which ones are you guys talking about so you could just clarify and stay on the
Just
same
just
line?
I'm
just
just
whatever direction is opposite of where the sun is when it's at its highest point.
So the South Celestial Pole is a spot in the sky that is relevant to the observer on the ground and moves with the observer on the ground. It's not a physical place on the ground. So if I'm standing on the ice wall and I start walking west and it's nighttime, the South Celestial Pole is going to follow me until I get out of the night zone into the day zone.
what if I'm on the other side of the rim of the flat topographical plane? Where
Then
is it
you're
in relation?
you're you're
Where?
you're, you're in the day zone. You're not going to see it.
Well, the night zone is fairly broad, right? So I'm in the night zone somewhere where you are not, right? So where would I see the South Pole?
Relevant to your position, looking south up into the sky.
But what direction is south?
Okay, so if we're both standing on a beach a mile away and we're both looking at the same sunset, does the horizontal path of light travel only to me, or does it travel to me visually and travel to you visually? And if we walk towards one another, it follows us until it meets us in the middle?
No, that never happens.
Yes, it
In front.
absolutely does.
No, it doesn't.
So if
Right?
if you're standing 10 feet away from me on the ocean and we're both looking at the same sunset, we both see a horizontal path of light across the water from the sun directly to us.
Yeah. What does that have
Okay.
to do with where the South
I'm
Pole
trying
is?
to get you to understand apparent position because apparently you don't understand it.
That might be true. You're talking about the path of light, right, from like say the moon or the sun to the observer, right?
In an
Right.
attempt to explain an apparent position, yes.
It looks like a path. It looks like a beam of light, right,
Run
on the
Boston
ocean.
Bear has it for his like picture.
It looks like a beam of light on the ocean, right? I'm not talking about that. I was asking where is the South Pole in your model?
That's what I'm trying to explain. If you don't understand apparent position, you're never going to understand anything I say.
Well, I would think that the South Pole is a physical location. It's not an apparent location.
Which one? The one in the sky or the one on the ground?
How dishonest.
I'm just asking. I was hoping you'd explain it, and I'm
Uh,
trying to understand. I'm asking questions to try to understand.
the sky, like it was being said just a few minutes ago, the sky operates with a kaleidoscopic effect. With a kaleidoscopic effect, you can have a central rotating star field that at the edges will have not only an apparent opposite rotation, but will be slightly different in a Mandelbrot sequence of the original. And
Yeah.
that all ties into fractals. And you wonder, well, where are the mirrors? Well, Job 37:18 says that the dome is like a cast metal mirror that reflects heat. So the dome itself is the mirror. The angle of the dome actually creates the kaleidoscopic effect, considering that we're looking at it from the inside. Therefore, it's a concave type mirror. So you're going to get a kaleidoscopic effect. The southern celestial pole is a kaleidoscopic effect apparent to the viewer, not a physical position.
Yeah, but
That's
I was
that's
asking.
the best I can explain it.
Yes, but I was asking about the South Pole, right? Because we have a North. Is there a let's switch to the North Pole. Get straight about that. There is a North Pole, right? And that's a real location, right?
There's like 9 North Poles.
There's only one.
There's
I
a
think
lot.
there's like 10, dude.
Yeah, there's like
Well,
they keep adding
there's
more.
Hey
There's
there's
Brenda,
only one. There's
ask
only
for the
one.
G. Hey Brenda, just ask for
And
the
they're all
GPA
south of each other.
of the
Yeah,
celestial
every
Because
pole.
North
they're
Pole
just.
is south of the other North Pole.
You sound like you're not serious. I'm asking Hanvey, and I'm asking seriously.
No, that's dead serious. That's your model.
Yep.
Every
I'm not
North
asking.
Pole is south of the other North Poles. Yeah,
I'm
I'm
not
that's
also
how
asking
being
they
about.
serious.
model.
I just think it's silly to ask for where the North Pole
Um,
is if there's like 9
well,
or 10.
but there's not. There's only one.
actually there's geographic north and there's magnetic north, so there are
Yeah,
two northern points. But you're trying to switch between what we call a celestial pole in the sky and a pole, the point to where the surface is supposedly under that pole, I guess is what you're trying to get to.
I'd say that that whole thing is the axis, right, of how the stars rotate around that axis, right?
You do realize that you cannot physically model star trails under the globe paradigm and the specificity of its claims.
But
It would not work.
I'm asking about your model,
No, see,
and
this is the problem. I don't have to have a burden of proof for a model that I don't even claim to be. All I claim it to be is proof of concept that it could work in a model like this.
well then,
You're making the positive claim that the globe model is true. I'm making the negative claim that the globe model is not true. Therefore, the burden of proof is on you. If you can't supply that burden of proof or we can falsify it, then you have the problem, not me.
He's
no,
right.
I was
That's
just
exactly right.
we started with Joe Hanvey giving us his hypothesis, and then I asked him, how he tested his hypothesis. He couldn't explain the South Pole, so I'm asking him to explain his North Pole, right? Which
So
we can see the North Pole because when you take a long exposure, you see the stars circle the pole.
if how many people in here think that I explained the celestial South Pole pretty well?
No, you
Also, Brennan,
didn't.
you
I
just
live in the south. I can confirm you
I
did.
equivocated North
understand
Pole.
Joe Hanvey.
I can
I
I
think
thought
you
it
confirm
was
got it
that.
good
right,
too,
Joe.
though.
Brennan,
I
you
thought it
just
was good.
said you can see the stars circling the North Pole when before you and I think it might have been Wesley, you were saying that the North Pole, there's only one North Pole.
That's
Well,
correct.
okay, so
Never
is
said
it a
that.
physical plate? Okay, maybe it wasn't you. Is it a
Hey
It is
physical
a
Joe,
place
you
or
apparently oh
is it
sorry,
a
you
physical
apparently
place or
explained it
is it a
bad.
point in the sky?
there is a point.
Joe, going back to your question, I live in the south. Your conception of the south is completely wrong.
Oh, the problem with the South is that they're not really Polaris privileged. So like Peru,
What
it's
does
just
that
horrible.
mean?
Like
Well,
I'm
Argentina, Peru,
That
a
that
lot
is
of those
just
guys, they can't even
like
see
whole
Polaris. You know
copium.
that?
You
Yeah,
guys can't
copium.
even see Polaris, dude. What are you
Yeah, that's a
doing?
shame. I do
I'm
feel
He
bad
just
for those
asking.
who aren't
I feel
Polaris privileged.
terrible.
I try to
Yeah.
advocate for them.
I'm honest. I'm being very honest and I'm being very forthright. I'm simply asking Joe to explain his model, right? And I switched to the North Pole because I couldn't understand his South Pole. So
Apparent
maybe,
position, dude. It's very
right.
simple,
So,
dude.
so maybe that would help me if we talked about the North Pole. The North Pole is a place I can stand on the ground and the central axis that all the stars rotate around will be directly over my head.
You'd have to
That's
go
the
there
North
at
Pole.
nighttime to prove that. No one goes there at nighttime. When has anyone gone to the North Pole at nighttime? Who would ever do that? That sounds dangerous, Brenda. That's probably more dangerous than going to the moon. That's a dangerous environment.
Yeah, it's
It's
a
actually
hazardous
not.
place to be
People
hazardous
go there all the
environment.
time.
Oh wait, hey Brenda, do you think you're
I see
actually seeing the
danger.
sun? When you look at the sun, do you actually think you're seeing
I,
the sun, or is that just the
I'd like to.
apparent position?
I'd like to stay with Joe Hanvey. I would.
I'm just asking you, do you
It's real.
understand what an apparent position means? Like
I'm being
that,
honest, and I'm very interested in Joe Hanvey's
I just
kaleidoscopic
want to
model.
know yes or no. Do you know what an apparent position means?
Yes, please, Steelman, apparent
It means
position.
apparent means what's visible to you. Your phenomenology.
No, it doesn't.
Yeah, that's literally what it means. It's phenomenology. It's what you see.
Phenomenology is like how a rose, when you look at it, it makes you feel. What are you
No,
talking about?
That's not phenomenology.
Yeah, but
Phenomenology is is your senses, what you perceive through your senses.
Yeah,
That's
like
what
when
it
you
is.
look at a rose, it makes you feel a certain way, and people try to talk about that phenomenologically. Yeah, we get it. That has nothing to do with the conversation.
all right.
It
So
has
what was being discussed was about the stars and my understanding, like ground position. So, if you have the entire rotation of stars in the north, and you were to go to Polaris, there would be a ground position under Polaris. Unless anyone's contesting that, there would be a ground position of the star we call Polaris, just like there's ground positions of the Big Dipper, the Little Dipper, etc.
Thank
So,
you.
I
Thank
think
you, Gio. That's
what's
great.
be,
Thank you.
so what's being brought up here is that you have the southern rotation. I think Brenda's asking, in the viewpoints being put forth, is there also a ground position underneath Sigma Octantis and the Southern Crux stars and so on? If those are at a fixed position, just like the ones in the north, then we're on a two-pole planar system. If somebody's going to suggest that it's only an apparent reflection on the outside, then what needs to be accounted for are the ground positions of those stars. And if somebody's going to claim that it's only a reflection or an apparent position, then there becomes the issue of the ground positions. Like, are there multiple ground positions for those stars at any one time? Meaning, is there a ground position for Sigma Octantis at multiple places at the same time around the outer rim of like an AE or Gleason? So I think that's what's being discussed. And
I think I think so. So I think that there must be a ground position for Sigma Octantis and for the southern pole of rotation, which Sigma Octantis is half a degree from. It's half a degree. So there's a ground position about which all the celestial bodies in the southern hemisphere rotate around that, right? Do we agree on that?
Okay, then why? Okay, then why is it the case? Because I agree, I understand what you're getting at, but why is it that people aren't going to the North Pole and taking time lapse photos of Polaris at 90 degrees? You guys even
Pretty
say
sure they.
Polaris isn't actually in the center.
Can you let
It
Joe
spins around,
answer?
and it's
Can you
probably about a degree in the sky, which is 69 miles. So that gives
can you
you
let
a
Joe
radius
answer the
of
question?
69. All right. What's going? Why
Can
am
you
I
let
getting
Joe answer?
interrupted? Why is
Well,
this
can you
guy
let Joe
interrupting me?
answer? Brenda asked a question to Joe, and so did
Yeah,
Gio.
but I'm
So
just saying, I think it's a little, I don't think you're being fair when you say there's one position on Earth underneath Polaris if it's got a
How
circle with a radius of 69
how
miles of where it could be.
how can there be two
Got
places?
him.
How can there be two places that are ground positions for an object?
She's
How is
missing
that
the
possible?
fact that she has a radius of 69 miles underneath Polaris.
all right, but that's
No.
a slightly different point. I mean, if we're going to stick on the whether the southern pole is an apparent position or whether it's a fixed with like the way the north one is with the GP,
It is.
then yeah, but
Where's the
that was on the
GP?
table.
Where's the
I mean,
GP?
Tora, what you're mentioning, like, I mean, my understanding of, I mean, they do have cruises to the North Pole that they claim, but there's only like there's very few of them per year, and it's about $100,000 to
You
take those
can't go
cruises.
there.
But
You
that's
can't
during the
go there in
That's
a
in the,
boat.
that's
that's
during the
summer.
24-hour sun time.
You
So
can't go there.
that's when there's a please don't interrupt. So that's when there's a 24-hour sun in the north is when they have those cruises. I don't know that they have any cruises like when it's the 24-hour nighttime. You know, in the north it's like extremely cold and the ice and everything. So I don't know. So Tor, I mean that whole question, like why hasn't anyone gone there to get footage underneath it? That I hear you, but you would agree it's somewhat of a non sequitur, right? To get into, you know,
Wait, can Joe answer the question?
yeah. Let's let
Uh,
Joe.
Joe, yeah.
all right, fine. I disagree that it's non sequitur.
Well, no, if
Hey,
you
I
want to
don't mean
continue
to.
on it, that's fine. But there was just, yeah. I mean, is
I
that
don't,
what
I
you
don't
want to
mean
go?
to interrupt, but Joe, I was asking who you were. When I looked at your YouTube channel, I'm already subscribed. I like some of the stuff you're doing.
Oh yeah,
Yeah,
dude.
that's
Joe.
weird. I was already subscribed to.
Joe, is there a GP for Sigma Octantis on your map?
So
Or Southern Pole?
this is kind of the beauty of this conversation. It could very well be a dual pole, still be a level surface with a dual pole, and the celestial kaleidoscopic effect still works. And then you do have a direct ground position to the celestial pole that we call a celestial pole for the north and south if it's a dual pole plane. But it also works within the physical model if it's an apparent position that's relative to the observer at any point in the night zone facing south. So
In your model, the stars in the north reflect to the south. I see a completely different sky. It doesn't work.
you don't understand Mandelbrot sequences, fractals, and a kaleidoscopic effect. You just don't. So even in this model, when I'm looking at the southern stars and the northern stars rotating and I'm videoing it, the clusters of stars that we would call constellations look different in the south than they look in the north.
Because
Why
it's
do they
different
look different?
stars.
Yeah, they're different stars, dude.
In my model, they're not. In my model, there's a single
Because your
westerly.
model is wrong.
How
Wait, let
does
him
your
finish.
Oh my
model?
gosh. Can
No,
I talk? Y'all ask me to talk and answer, and then you interrupt.
Yeah, you guys don't interrupt anyone, please. Don't. No one
I'm
interrupt. Go ahead,
trying
Joe.
not. I'm not, Joe.
Thanks.
I'm not
Go
doing
on.
that.
Thanks. Let Joe finish. Go ahead, Joe.
If I can produce, like, I can go out to my front yard and I can position my camera to do a time lapse or a star trail shot to where I can catch northern rotation, equatorial rotation, and southern rotation from my house here on the East Coast. I can position a camera underneath inside the dome looking up, run the stars, and capture the same thing under a time lapse long exposure.
Have you done
Yeah.
that, Joe?
Yes, I have. The videos are up.
You have. Let me be clear. You have video of the southern pole rotation taken from California.
You can see part
If
of it.
California's on the East Coast, then yeah, because he said East Coast
But he said.
specifically.
I thought he said California. I thought he said East Coast or
I mean,
West Coast.
you can see part of the southern rotation, like from Florida, for example. You can see a part of it, depending on your visibility. Not that you're going to see the entire like Sigma Octantis
Yeah.
region, but
Yeah.
you'll
So
see
you
the
can't
top.
see it.
You'll see the
So you
top
can't.
part of it.
Yeah. So you can't see it. You can't then, right?
You can see part of the rotation, which may be what he's referring to. I
Right.
think we can move
So
past
you
that.
can't see. So you can't see Sigma Octantis.
I'm agreeing that we see
No one can
what.
see Sigma Octantis. It doesn't even exist.
Yeah,
I can
You
see
can't see
Sigma
it.
Octantis.
yeah, it does exist. You can see it with a telescope from people I talk to that are in New Zealand and Australia. Um,
Why can't you, Joe? Why can't you see it?
because I'm too far north.
Vanishing point.
Why? 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 What difference
Op-
does that make?
optic limits.
What limits? You can see all the other stars.
No, you can't. You can only see we can only see the northern stars from the north. That's it. We don't see. Now we can see a small portion rotation that has an apparent opposite rotation. We can see that curve. Then we can see the equatorial trails, and then we can see all the northern stars. Well, not all. We can see all the northern stars at their
That's
specific times during the year. But we can see all three. We can see that
okay.
counterclockwise. Hold on, let me finish. We can see that counterclockwise rotation in a time lapse, the equatorial lines and the southern lines all in a single time lapse from the north. So we do know that we're seeing this apparent opposite rotation, and it has to be an apparent opposite rotation because they are both moving west.
Wait, why are you saying opposite? They're both rolling in the same direction.
Because there's an apparent counterclockwise and clockwise rotation. So when I'm
That's
looking
only because
up,
you're looking. Wait,
when I'm looking up in the north, and I'm
no,
looking
they're both clockwise if you're facing the poles.
No, one is in the south it's clockwise and in the north it's counterclockwise.
Well, but they're both going west.
Yes. because we're antipodal to each other. It's the same problem with the sun, the way the sun sets.
Okay, yeah. I mean, technically but it's not really counter to the roll. The roll itself is all rolling in the same direction.
It's east to west, but the problem is that because I'm upside down relative to you, it changes the direction. It flips the direction.
Can you just say sweater straight to jail for me? I just need to hear it one time.
No.
Yeah, I like your accent, man. It just reminds me of a skit.
All right, dude. Joe, do you remember what you were saying last? I think you got a little bit interrupted.
Yeah, I mean, like I don't know how much better I can explain it. So it, like I said, it can work as an apparent position relative to the viewer in the night zone, no matter where they're at in the south, facing south, looking up at the southern sky for themselves. Or it could be a dual pole system to where there are two rotating star fields, one over the northern pole of the level plane of Earth and one over the southern pole of the level plane of Earth. I don't know what the surface looks like. I don't claim a map. I don't claim a model as far as based off of a map because I don't think we have a truly accurate map from either side.
Oh, we do.
And
It's a globe.
yeah,
Yeah,
you say that with such confidence and you're just
Yeah, because
wrong.
I live in the south.
Yeah, I live in the north. So what?
That
yes. I mean, I think
flat
what
Earth
you
works for the north, but not the south. That's a
what
problem.
So
what you
you
just
live in the South and you think that makes you special because you live in the South. I talk to plenty of flat earthers in Australia and New Zealand and South America and plenty of places
Not
in the South,
plenty.
and they disagree with you.
They
Well,
are
they're
flat
idiots.
out lying.
20 Southern
yeah.
Hemisphere flat
So
earthers
what
are
Joe
the
just
dumbest of the dumb.
yeah, hold on, dude. What Joe just laid out is the difference of what's being discussed in terms of the northern and southern rotations. So one of them would have, fixed stars. Like I've always said this idea, whereas if you took all the stars and just freeze framed them, like, you could hypothetically just put a pause on the sky. And then right at that moment when you pause it, let's say it's nighttime everywhere in this hypothetical, and you go and you put a little flag in the ground under at the GP of every single star. So you put a flag under the Big Dipper, under Polaris, like under every single star. What would you end up with? Would you end up with two massive swirls, like a double toroid? But would you end up with like two massive vortices of rotation, just like we see the two star trails in the north and south, and then at the equator, at the equatorial, they're going straight. Well, they're kind of blending and going straight at the equator. Is that what would be on the ground? And then if all of those stars have fixed GPs, then you would have like two fixed poles on a planar surface. Now, with the azimuthal equidistant map kind of layout, it has the one pole in the center and then extrapolates the Antarctica as the rim around the outside. And so that's where, and even before TFE and even going all the way back to 2015, 16, 17, there's always been that discussion of the southern stars. And back even before Discord was even a thing, like Bro Sanchez used to do big debates on his channel with like a couple thousand people watching, and the Globe guys would come in and be like the Southern Stars, and they would feel like it's like they're dropping the bomb on everybody, and they felt like it couldn't be rebutted because a lot of the flat earthers at the time were supporting that azimuthal equidistant type of map projection. So the Southern Stars, and I mean Whitsitt, myself, and others, we've all discussed over the years like different potentials like reflective effect, the corpuscular rays effect, where you get the symmetrical corpuscular rays, and we could get into all the details of some of those arguments and so on. But yeah, I mean, what's being discussed in terms of whether the southern pole is like an apparent type of position that's like a reflective nature, and but on the AE map, for that to be the case, it would have to, like, the GPs of those stars would have to move basically as you move around the outside. And I think there are some inherent issues with that with the GPs, but I mean, some of that would need to be like further verified. Then there is the Amundsen Scott base station as well at 90 degrees south, which like Whitsitt was saying, that woman that was there with them in Union Glacier, she was going through Union Glacier, and it was like a short flight to get to that 90-degree point, and so on. So then there's the whole question of, can you reach that 90-degree point from all the southern continents in a relatively equal travel time,
Yes.
which, rather than the azimuthal equidistant of it being spread around the outside. So yeah, I mean, that's kind of what's in, the difference between, let's just say, like a dual pole and then a single pole azimuthal equidistant when it comes to the southern stars, and then the southern sun kind of makes that more complicated only because the sun having one like dramatic GP in one position, the 24-hour sun obviously kind of accentuates that. But I'm just saying that the stars in the south have been kind of a question for that azimuthal equidistant, for ever since it was, first been being discussed and so on.
So, I mean, let's knock them down one by one. It can't be reflective because it's different stars, right? And yes, you can get to the South Pole in roughly the same amount of time from South America, South Africa, and Australia.
Yeah, I mean, from at least, I've never been to Antarctica, but my understanding, yeah, there's a company called White Desert in South Africa, and there's a couple different camps that they have that are over on their side, as it were. McMurdo is, within the region of New Zealand, Australia, and then Union Glacier is south of South America. And then my understanding, at least from what they claim, is that from the White Desert Company, like those trips are like $100,000. They have a short flight that you can take to the South Pole as like you can pay extra to go to the Amundsen Scott station. Like I said, the evidence of like Whitsitt and those guys being there, and the woman that was traveling through, and the fact that also ALE has a trip. They have a camp at the South Pole as well. They have a trip there. That one's also like $100,000. They have a camp there as well. It's like a smaller camp, and so they do take trips there. And then lastly, McMurdo claims to also have flights that are, fairly short to the South Pole. So I'm just saying, like,
Why
what you're
do you
saying
keep
is
bringing up the price? Because you seem to think that the price is somehow a locking mechanism. A Ferrari costs millions of dollars. It doesn't change the fact that if you have it, you can buy a Ferrari.
the price doesn't matter that much. Only the fact that it's 100,000, so it's like 3 to 4 times what the other trips are, and it just is what it is. To do the White Desert trips, they're about 100 grand, and then to go to the South Pole, it's about 100 grand. It's not really a particular point. I'm just saying that that's my understanding of the situation, and so perhaps that's why if none of us know someone that has paid the 100 grand to go to those particular sites, I'm just saying that that's what's my understanding of what's claimed and the trips that are offered.
Yeah, just asking for the relevance of the price. I don't. It seems that you're going back and looping back into the price of something when it's a huge.
No, it's just an informational add-on. That's all. It's just an informational about what's claimed.
Punta Arenas is 1,500 from the US. Anyone can go. We're going back in December. Anyone can join us.
You can do it for about 60 grand if you're not going to stay overnight. If you're not going to stay at the South Pole.
Yeah, I mean,
if you're just going to fly in and fly out, you can definitely go to the geographic pole for under 60 grand.
ALE has a ski the last mile or ski the last degree, they call it, where you go to like 89 degrees and then you ski 69 miles to 90. They have that trip too, which I think also is 80 or 100 grand to do that one.
Yeah, but that's a lot more involved than just flying in and flying out, because then you're going to have to stay and set up camp and stuff, right? You're not doing that in a day. Either way, it's expensive, but there's lots of exotic places on Earth that are expensive to visit.
Yeah, I mean, I guess at the end of the day with the GP situation, it would just be what I would want to see. Like if the Southern Stars were just an apparent kind of reflection. I know, Max, you said that they're not an exact reflection. I hear you on that. When I don't think anyone's suggesting it's exact, but there are some ideas that you can, like, if you know it, like chiral and non-chiral, you can have like self-similar reflections when you look into like chirality. It's pretty interesting. So I mean, there are those ideas. But either way, I'm not finished. Either way, the thing with the GPs is simply that if it was an apparent type of reflection or position, you should be able to, in theory, have somebody in the south that has a GP, and then somebody that's at the GP of a star, and then somebody else that's like 10 miles or 100 miles to the east or west would also be at the GP of that star, and you should be able to simultaneously be like, okay, we're both at the GP of the star at the same time. That's to me what would be needed for it to be an apparent type of effect on the outer rim,
But
is that
that
that there would have to be more than one GP for a celestial body.
But
it
Gio,
doesn't
you
happen in
understand that,
reality,
like,
though.
in the southern sky, there is a bunch of very unique astronomical, like planetary nebulas and things like that, that look nothing like the ones we have in the northern hemisphere, right? Like, they're unique galaxy clusters, unique galaxies. Like, you cannot say that it's just a type of mirroring. They're literally completely unique things that are in that sky.
Yeah,
Very different.
I wasn't making the argument for it. I was just saying
Uh,
that there are some people have ideas that, and since they're not exact replications, it would be like a non-chiral type of scenario where there's a self-similar but not self-identical reflection.
yeah. So do
Which
we?
that doesn't help you either. It's chirality doesn't help you in the stars because they're completely different. They're not even chiral images of each other.
When you look into a kaleidoscope, how many people here understand how the internal aspect of a kaleidoscope actually works?
Yeah, it's a bunch of mirrors and beads.
Okay, but you have a central image. So in the center, you get a perfectly radial repeating image in the center, and then the perimeter images around that center, which would be like your southern sky, will be different, but they are still perfectly radially repeating in the opposite direction.
Which doesn't happen in reality.
Yeah, I mean, the sky is full of unique constellations, unique stars. Some are binary stars, some are triple star systems. You've got like all the different, you know, clusters, right? You have, planetary nebula, like the Ring Nebula, and then all the NGC objects that are like harder to see without like a higher end amateur telescope. These are all completely unique things, right? If what you're saying is true, that it's just a bunch of mirrors that are like turning it into, like a kaleidoscope, then we should be able to locate those objects in multiple places in the sky, but we can't.
That's
They're
not
always
true. That's
completely,
not
they're
true.
in
You don't.
unique, discrete locations within the sky.
You're not understanding the kaleidoscopic effect. I mean, that's as simple as I can put it. Because
Does a kaleidoscope have repeating patterns in it?
Yes.
radially repeating.
Again, what do you
Radially
mean by
repeating.
radially repeating? That's not saying anything.
So the image is different. All of the images in a kaleidoscope come from the central image, the light input into the central image. So the
Again, you're not
central.
saying anything.
Well,
Are you saying that you think the sky is like a kaleidoscope?
Yeah, let's just
Yes.
let's try not to interrupt people. So Joe's in the middle of speaking. Joe, you can finish your point. You don't need to interrupt him to say you're not saying anything. Go ahead, Joe.
yes, I'm saying the sky is giving us a kaleidoscopic effect based on the modeling that I do and what my assumptions are about the sky system due to what the model produces. Yes, that's what I'm saying. Plus, there's scripture to back it up, and I'm a biblical cosmologist, so that's where I
Whoa!
stand.
What
I,
scripture
I
backs up
Biblical
post
the? One second.
cosmologist. Wow.
What scripture backs up the kaleidoscope celestial model?
So is a kaleidoscope made up of a bunch of mirrors?
I mean, I said what scripture. That is answered by chapter and
I'm
verse.
I
asked.
mean, you keep using this example of a kaleidoscope. I posted a picture of a kaleidoscope. You can see very clearly that the patterns are repeating because they're being mirrored within the kaleidoscope. So if what
Yeah.
you're saying is true, we should be seeing repeating star patterns, Bezier objects like NGC objects. Like we should be seeing repeated variations of that, right? Because it's being reflected by the dome or whatever you're trying to say.
We should also just be seeing inversions, which we also don't see in the sky, and that's really just what a kaleidoscope is. It's just inverting patterns.
And when I asked about the scripture, that question is answered by chapter and verse.
So
But
so when he says radially, what he actually means is inversely. But he's using incorrect words.
What word did he use incorrectly?
When he's using the term radially repeating, it's not the correct term to use.
I can
So when we're
literally
trying to
show
like,
you. I can literally show you videos about kaleidoscopes where they literally use the word radially repeating patterns.
That's
what
fine.
is
It's a myth.
radially
Don't
repeating?
worry about that. What
Yeah,
you
it's
can
it's,
show
ins-
me
it's
is the sky doing that in my night sky right now, for example.
Well, if we're going to be talking about like math and geometry
y'all.
and things like
You
this,
guys think
we
you
have to
think
make sure that we use proper terms that like people can actually understand what the fuck you're talking about, rather than just some made up stuff.
you think that lights in the sky should be the same because they're reflections. But I'm not saying they're just simply reflections. There's a lot more going on with a kaleidoscopic effect than just reflections because you're getting different patterns from the same central image. I don't know how much more simply I can put that.
So
And
what
I really don't care. I mean,
in the night
honestly,
sky?
can I finish? Because I'm gonna finish with this and then I'll kind of hang out. But I really don't care to prove anything to anybody. That's never been my purpose for this. My
We're
purpose is
just
just, can I finish? My purpose has been a learning journey, and all I'm doing is sharing what I'm able to learn and what I'm able to mimic. And I can go into this physical model and I can take a long exposure and I can get northern trails, equatorial trails, and southern trails that match what I see in reality. I challenge any glober to set up a physical globe model where the globe is tilted, spinning, and moving in a corkscrew motion while moving with the sun in a star field and to produce those results. If you can produce those
Super easy.
results, do it
The
then.
problem is that I
Wait,
go
wait,
Do
wait,
it.
wait,
outside
wait,
and
wait. Let me answer.
I go
Let me answer
outside
that.
and it doesn't match my reality, which is me
So,
looking at the actual thing, which is the sky. So I would appreciate it if you would just stop lying about the South. Thank
so
you.
let me just make something clear. It's super easy. There's a huge misunderstanding about all this corkscrewing and wobbling and whatever else you said. So the stars in the model that we're talking about are, thousands or hundreds, some of them are millions of light years away.
So you can't physically model it.
Yes, you can model it in software. Are
Okay.
you saying it has to
No,
be a big
physically.
diorama with
No, it has to be
with
in a
little
bucket in
hung
the lab.
styrofoam balls?
What's a bucket in a lab?
No, physical
I mean,
model.
if that's the standard,
Oh, dude, wait, omnivore. That's not a standard, a physical model?
No, physical model is not
it's
required.
not
Oh,
it's
so
it's
you
not a
guys don't have a
standard that
physical
is.
model that you guys always
What do you want? You
claim
want it?
to
I'll
What do
have
you want it
do
made
that
out
you
of? Paper
say is
mache?
in every, excuse me, it's in every classroom. I've heard it claimed by many Globers that there's a physical
Let me know
model
when I
that's
can
in
answer.
every classroom.
Yeah, it's called the globe. Yeah. What do you want? Do you want it
So
in paper mache
yeah,
and
it's a
painted with?
goofy standard. It's a goofy standard of evidence that you're trying to require. The
So wait,
model of
But y'all have
the
been
star.
asking us for
The,
years to
I'm just
give
gonna.
you a
I'm gonna.
model to model
I'm gonna
Yeah,
stuff.
any
answer the
model.
question. I'm
Yeah,
gonna
any
answer.
model
I'm
would be
gonna
nice.
answer
Yeah.
his question. The modeling of the stars is not something that exists in any classroom. The idea of physically modeling the stars with a
You don't know what
accurate
a
distance is
planetarium is?
not something that the model either claims you should be able to do, nor that you would want to try to do.
well,
That's
just to
how it
put the scale into perspective, if you were to model a solar system in your living room where the sun was at the center of your living room and the Earth was
Well,
2 feet and the Earth was 2 feet away from your sun, the nearest star, right, Alpha Centauri, would be about 100 miles away. So
Awesome, dude. Good
I don't know
thing.
how
Yeah,
he
good
expects
thing we
that.
don't need that.
Yeah, let's
We don't
build that,
need any
guys.
of that,
Let's
dude.
just build
It
that.
doesn't matter. All
Well,
we
it's
have
a,
to
it's a
do
goofy
is
standard of
make Joe
evidence, right?
Hanvey's
It's where
model.
it
We could
says
just
this is
make,
what I require, and
dude,
that's what I demand,
dude,
and
excuse
if it
scale
me.
doesn't meet
scale
that,
is a bit.
no good.
Excuse me. We don't have to do
Goofy.
everything that
I'm
you
sorry.
just claimed in order to replicate reality, that we need to put something this far away.
Exactly.
We can replicate reality here on a table.
Yeah,
What are
with
you
a
but you
talking
can't.
about?
So we do already have that model. It's called the Universe Sandbox, which incorporates different constellations during different times of the year, accounts for the axial tilt of the Earth. So I'm not really sure like what you're whinging about when you demand that we have a certain model that can show these things. It's
So
done. It's just
yeah, software works fine for that. But I think that I just want to address what
So
Joe
you guys
said
do not
about
accept
the
physical
Hold
wobble
on
models,
a
is that
second, you
correct?
guys. Hold on, Tora. Can you hear Omnivore? You guys are just over talking each other. And by the way, Joe, I know sometimes this format is because of all the clipping and interrupting. We generally tend to let everyone be here, and then when there's a lot of people in here, it ends up being like we can do other style shows where it's more like a stage channel or where people can't interrupt like this. But with this open panel, so yeah, I know it can be frustrating, but you guys, there's a lot of people in here, so can we all like really, really try to not just clip and interrupt? We have to wait till someone's like completely finished, in order for this to be
Okay,
orchestrated.
well, I
Right?
wanted to yeah, I wanted to respond to that. Let me know when I can. Tora, if you want to get in or something.
Go ahead.
Just to be clear, the the model that we're talking about, the heliocentric model with the stars and stuff, makes it extremely easy to model all of the stars and their regularity with the motion because at the distances that they exist at, the sun and the wobble of the earth and the tilt of the earth and all that stuff is just barely crawling an inch a year while these stars are out there. These movements that seem so fast in the scale that we're talking about are all essentially standing still, which is why we don't see the sky going random despite having all of this motion. That's just a misunderstanding of what the model says.
So standing still while traveling at 1.5 million miles an hour. Gotcha.
Hey, you don't feel motion.
Yeah, we have a
Well,
model for it.
you know how long a light year is.
I
It
just
suddenly
want
makes sense.
I just wanted to be clear that you guys are saying a physical model that I could reproduce in my living room is worthless, right? Is that correct?
Well, you guys are painted
Done
with
to
is it made
scale,
out of
it
paper
would
mache?
be, yeah, it's not going to
Does
work
it,
for you done to scale.
does it have
Is
better
it,
explanatory power than the globe, and does it make useful predictions, Tora?
I'm just asking. I just want to make sure that we have this on the table, guys, for everyone that, is attempting to make a model or anything. These guys will not accept a physical model that you can literally give them a list of supplies that they could go and make at home and it depicts reality
Do it.
accurately. They don't
is
want to
this
I'd love
do
to
that.
see it.
you make it out of paper mache and color it
So
with like a matte paint like you did in sixth grade?
that,
The
in
reason
terms
is
of what
because they know they can't reproduce it. It's very simple.
in terms of what
Problem
a
is the
model
scale.
is in science, a model is something that has predictive power. If you want to build a diorama, like a grade school diorama of the solar system, go right ahead. If you're going to try to build a diorama to scale of the galaxy, yeah, that's not going to work. That's
Wait,
just
what was
how
wrong
the
with what
So,
Joe
physical
presented?
observations bear out.
so if,
But the
yeah,
Hey, omnivore. Wait, you said a model has predictive power. I thought that
right.
was just a predictive model.
No, generally speaking, when we talk about models, we talk about something that is predictive. A
You can
hold
simple
model
on, let
anything.
Joe,
model.
hold on, Beast,
And,
let Joe
Well, wait,
get in. Yeah, because
and,
hold
we're
on,
and
talking about
guys, let Joe get in. You guys there's a lot of Globers going. Joe's barely speaking. He should get double the mic time without you guys going that much.
don't interrupt them, Torah.
So in my hypothesis, I was like, if I set up a dome model, I should be able to recreate star trails. I set up a dome model, I'm able to recreate star trails. That's not predictive.
Sure, you can.
So what do you mean
you,
that's not predictive? So can it tell I don't know when Polaris will move off of the North Pole the current North Pole?
Does it have
Sure.
better
That's pretty funny.
explanatory
Can you
power
can you
and better predictive power than the globe? That's the question.
can you
Has
Or
that
know
ever even
what's
happened
something?
the best
before?
model?
Yeah,
we
can you
could
know
Listen,
something that nobody knows?
We could
let's
start
let
really
Joe.
simple.
Let's
Just
let Joe respond.
we could start really
So
simple. Point out the six Polaris near the North Pole, and then point out Sigma Octantis. Where would these be on this model? Is you could consider it. I'm not saying you have to. Globers you guys are jumping too far ahead. We don't even know where fucking Sigma Octantis is.
Yeah, we do actually.
I mean,
Talking
the thing
about
about
in their model, excuse me, in their model.
the predictive stuff though is every year there's a book published called the Nautical Almanac, and it tracks the motion of the stars.
Predicts the
It's
motion of
only a
stars.
little bit, but it does track them over each year, and
It
we do
predicts them.
that using the ephemeris. So we do have predictive capabilities for it.
But you
So
said the
That's
North
the thing.
Pole. You said
It's on
the
track.
Polaris,
Excuse me.
bro.
Okay.
Polaris
well,
doesn't
Polaris
move, does it?
also, if Polaris does move a little
You
bit.
sure
A
about
little bit.
that?
Yep.
Yeah, a little bit. It's not perfectly on the pole.
I don't know about that.
You go
Polaris
look.
moves
It's
in a
not perfectly on
circle.
the pole.
Yes, Polaris moves.
A very small circle, but
So
a circle nonetheless.
if your system is tracking that, and it matches the ephemeris, that's a pretty good start.
It's small. That's a small enough circle that it's good enough for like 90% of the uses of finding north by Polaris.
No, he's talking about the precession of the equinoxes, though, where Polaris is going to no longer be the
Right.
pole star.
That's a 26,000 year cycle.
I mean,
Well,
that's
all of the stars do.
that's the claim, because the globe model has a physical ball that is actually wobbling, and then the stars, which are essentially fixed, even though they're very far out there. And the fact that you're on an actual sphere, and they account for the precession of the equinoxes, which is really just where the sun is on the equinox in relation to the fixed stars throughout the years, and how that changes very slightly. But on a stationary planar Earth, you really don't need Polaris to move like that. Other than the small circles, because the difference is that it would just be an effect of the sky. Like the stars and the sun are at their own pacing, and they have a slightly different pace to them, which would account for that. What I'm saying is that the only reason you would need Polaris to move is if you invert, instead of the sky being its own field with the stars and the sun moving at slightly different rates and the ground being stationary and planar, you have the explanation that, well, actually we're on a ball, and then that ball is rotating, and then the celestial sphere stars are way out there. And because they have to claim that the explanation would be that the ball is wobbling, then because it's actually physically wobbling, they would need the axis to slightly shift. So it's really only a globe
Well,
that requires
what's
that.
the explanation for what's driving the movement of that precession on the flat Earth then? And then what's driving the proper motion of stars like Bernard stars that are rapidly moving
Sky
across the
moving.
star field? What's causing those
Polaris.
stars to move?
Polaris
Right.
has proper motion too, Jake. They've measured proper motion on Polaris. It's not just a precession thing. It has proper motion.
This has nothing to do with the wobble. The wobble is not the cause for this. That's not true.
For the precession of the equinoxes, of course it is.
I mean, the main reason why Polaris is going to move away from the pole star position is not from its proper motion. I didn't realize that it has very much proper motion because it is so far away, but it is from the precession of the Earth's pole, of the axis of the Earth. I mean, it is processing
And
on the
again,
26,000 year
gotcha.
cycle.
Yeah. Two different
I hate
things here.
this.
So one is its movement relative to the rest of the cosmos, which is the proper motion. And the other one is its movement relative to the Earth's orientation axis, rotation.
And
I
we know this
I
is
hate to stress this, but like Joe, would you agree with a good model should make useful predictions that come true in reality and should have good explanatory power? A model that should replace another model has to do those things better than that model. Do you agree?
Yeah, we have both of those.
No, you don't.
Yeah, right.
Not really.
Are you guys? Let's let Joe
Sound like
respond.
Joe.
Please, nobody interrupt. Please go ahead, Joe.
Yes, I would absolutely agree with that statement. I don't know why I wouldn't agree with that statement.
Okay, and how does your model accomplish those things?
Well, you got to give me time. Like I'm again, I've made it very. See, I mean, you guys can laugh, but are you doing anything, or are you just sitting in lives and punching on keyboards on how everybody's stupid while spewing the stuff you've been told your entire life, or are you actually
Yep.
trying to model stuff?
Yeah.
Yeah, forget that. That guy's just trying to interrupt and troll. Did you want to finish your point?
Yeah, a couple of days ago or a few weeks ago, I was told that the Go Fast rocket and the view of the moon were impossible for the globe. So we pulled up Blender. I set up the Go Fast rocket. We figured out what its ground position was and where the moon was on that date, and showed that in fact it was reasonable that the footage from the rocket could see the moon where it was.
So Shane St. Pierre and Allen's model in space audits that does all of that. It's just as predictive.
No, it's not. I haven't seen everything they've done. I saw the last thing they published, which had the dome, and that's not predictive. That is reverse engineered, and there's no explanation other than that a person somewhere in the middle of that dome just sees whatever stellarium says they should see, with no explanation for how actual
An
stars get to
observer
those
observes what they
viewpoints.
observe.
So
Wait,
no.
the
So,
model that they made, omnivore, that includes the globe is wrong.
so
What's
your
that?
model,
Oh,
your your
They
model has
made they made the conceptual model in the computer and it includes a
No,
globe. You're saying that model's wrong.
no, no. Not
Okay,
true at
so
all.
Shane's model does have the predictive power
No, it
and
doesn't.
is the
No.
same model.
Shane's model is using a globe transform. It's taking the ephemeris and using a globe transform.
Yeah, and it has all its own measurements and everything. It's
It
done
does
in
not.
Lees.
It
Yeah, it
does not.
does. It has all of it done in Lees and it can predict anything you need in Lees.
what's a
stop playing.
Lee? What's a
You don't even
Lee?
know what a Lee is.
No, I don't know what it is.
Yeah, I question this.
It's like
No,
a mile. You know how you have a mile? We have
like
Lees, bro.
20,000 leagues under the sea. No, that
No,
seeing that
Lees, bro. Lees, dude. Like
What's a
not
Lee?
Levi's, just Lees, bro.
Can you give me a dictionary reference? I don't know what that word is.
The unit of
What it is
measurement.
it's a ratio that can be developed based on the angles to the stars that you can create any word you'd like. If you want to put miles, feet, inches, whatever you'd like, that ratio exists all over the world. So what
Oh,
we
well,
can do is we can conceptually model this in the computer, and Shane and Alan have done that to the point
okay.
now that it includes the globe. So if you deny that their model doesn't have the predictive power, you're saying your globe does not have the predictive power. It's a
No,
How
defeater
many
to
wait,
your
leads?
argument.
How many
wait,
leads in a
wait.
mile? How many leads in a mile?
That
You say
doesn't matter. Do you know that 1 mile is because you have a 69 degree, or you have you went 69 miles on the earth, right? And you have a 1 degree change in the sky. At that point, what did you work that off? Paces? Did you go over flat ground? How'd you get that measurement?
Well, we know what a mile is. It should be an easy question. How many
Yeah, you
leagues?
got
We
the
can. I can tell
mile
you how
from
many.
the sky.
Hold on, I'm still talking. I can tell you how many kilometers are in a mile. I can tell you how many feet are in a mile. So if a lee is something that we can all use, we should be able to convert to miles. So
Yeah,
what's the
what's the
conversion?
formula? What's the
It's a
formula?
rate. It's a ratio, guys, of
Yeah, what is
how
it?
you have
What is
one
it?
of six. You have a ratio of 60 to 1. That's not necessary the ratio that you have to use. You can use many
What?
different ratios. Yeah, you've
Oh,
decided that there's 60 nautical miles per 1 degree, and that's where all your measurements come from when you tell me of distances from different cities.
what is the formula for a Lee?
It's the ratio of the angle change over the amount of space, however many grids you want to put on your map, whatever. So just like pi is the ratio of the circumference to the diameter or the radius of a circle, that's how we made maps, was based
Okay,
off
let's
of
get
a
back to Joe.
ratio.
Let's let
How
Joe
how
talk.
old is this guy? Jesus
yeah.
Christ.
No,
I
let Joe
About
go.
five.
We've heard enough from Torah.
Yeah, I
I
would
still,
just. I'm not really positing a replacement model with a physical model. I'm not positing that. I've never made that claim. I've been very clear about my claims. I'm a biblical cosmologist. I believe the scriptures are true. I believe the scriptures tell us that we have a celestial dome that encloses our atmosphere and that there's waters above that celestial dome, that the plane of Earth is the base of that celestial dome. The entire universe is contained inside of that celestial dome or is projected through. I don't know. It could be either way. Um, all I'm doing is saying, hey, when I set up a physical model of what I believe the scriptures describe, I can account for the things we see in the sky visually. I can take long exposures and get the same thing in the model that I can go out and take long exposures and get in reality. That's it. I'm just saying that it's proof of concept that this stuff is not exclusive to a globe. And I'll go as far as to say that you cannot, and y'all admitted you cannot physically model it, and you attribute that to scale problems,
Yep.
but you can only digitally model it. You cannot physically model it.
You don't have to.
Amen.
Yeah, that's just a goofy. That's a goofy demand.
I mean,
Well,
they're not.
and
It's not
so
demonstrable in the
Let
lab.
me ask you this: in your
Again, hold on.
model, can you place a camera inside of your dome and have all the observers that are within it only see one sun, and have the South Celestial pole where the sun goes around there, without anyone else being able to see two suns anywhere else within your dome?
I've put cameras in the model. I've shown from 4 different viewer positions how they only see one rotating sun. So, like I don't I don't really bow to people's demands, but I've done all that. I've posted the videos. I've shown it. I've explained it as best I can. I'm still learning. I'm still trying to figure this stuff out. I'm still testing. I'm still hypothesizing. I'm still trying to figure out how to set up more and more demonstrations and get better and better at explaining it and understanding it myself. So, like, this is a process. That's what science is. Science is a process. It's not like, oh, Joe should have this model perfect in less than a year. I've only been working on the model side of it for roughly 3 years, and I wouldn't even say 3 full years. I started acquiring the stuff to have the physical model about 3, maybe 3.5 years ago. And I spend a lot of time just testing different things. So it's not something I'm going to have. It's going to take
but
me probably years and years and years before I have a really good grasp, but I'm starting to understand it on a much better level and a much better way of explaining it and tying in the sciences like atmospheric lensing, atmospheric mirroring, refraction, dome refraction, all of
Can
this different stuff.
can I ask?
can
So
you give us? Can you?
Is it
Hold
based
on,
on
dude.
the
Let him finish.
North Pole at the center setup? What setup is it? I don't even. I'm not even gonna ask map. Like, what's the
Yeah,
general layout?
I'm looking at your video, Hanvey. Which video would be the most like the one that has what you're talking about, where I can go look what it's like from inside and from the different angles? Like which video on your channel? 'Cause you have a bunch there. Which one should I look at?
And what's one of your hypotheses that you're working on?
Hold on a second, Robert.
Okay,
Which
sorry.
one?
yeah, I don't really, I mean, without seeing
But
what you're looking at, I don't know by name which one, but like if you're on my TikTok, I'm pretty sure one of the more recent ones where you can see it should be the still frame should look like a star field, and then it'll say equatorial, clockwise, and counterclockwise in the frame. That's a fairly decent one. I mean, probably several of the videos, I have the camera inside, I have the camera outside, I have the camera above, I have the camera out to the side, I have it looking up from underneath. Like there, I have it with what I consider to be a superfluid ceiling, without what I consider to be a superfluid ceiling, with an personal azimuthal dome, without a personal azimuthal dome, and I'm getting the results visually that we see in our sky in all of those scenarios.
Awesome, Judge. Yeah, I think it's awesome the amount of work you put in.
Wow.
Hours
So
and
so
hours just grinding.
I wanted to
I
correct
just
one
Yeah,
thing.
yeah. So anyone who it doesn't accept physical models, please just step down. And anyone that
Look, hold on.
actually is interested in a physical model, then might want to get their question in, because all of you Globers have said you don't accept physical models. So why even bother?
You don't
that's
have
No,
a
not
look,
true.
model.
physical. Hold on a
That's not
second.
true.
Physical models are not a prerequisite to having a good model. A good
Okay,
model
yeah,
makes
I'm
useful
asking
predictions.
people.
Wait a second. I'm
Okay, I'm
not done.
asking
I'm
people
still
that
speaking,
actually do
please.
like
I'm.
physical models.
Oh, I love physical models. They're beautiful. But what we're
Physical models
talking
are
about
great.
is a model that makes useful predictions and has explanatory power. There is no physicality as a prerequisite. It can be a
Right.
computer, it can be a mathematics function, it can be whatever it is. Whatever makes useful predictions is the model you go with.
We have that too, dude. Dude. Okay,
If
we're talking to Joe Hanvey. Joe Hanvey has a physical model, so people that are interested in physical models, maybe with questions. But otherwise, if dude, you guys are like terrible, and you keep
Okay, I hear what you're
attacking.
saying, Torah. You One
You keep
thing I want to respond to.
attacking it and saying, "Oh, it's paper mache."
The
That's
reason
very
that I
rude,
mentioned it,
dude.
I'm in a child's classroom.
give me 1 second. The
I
reason I wanted to mention it, Torah, is because Hanby said something to the effect, and correct me if I'm wrong, Joe, at the very end where like you guys don't even have a physical model or something to that effect, which is not a requirement. I want you to change your way of thinking because it's not required. If you have a model that makes useful predictions and has
By what
explanatory power, that's all
standard?
you need.
By
So
what
how
standard?
for how many
Yeah, but what
years
standard?
for how many
Science.
years
Reality.
for
Reality.
how many years have globe proponents said, give us a physical model, show us a physical model something for us? Because I've been in this for many, many
of the
years,
Earth, of the
and
no,
Earth,
I've heard that a
Let him
lot.
finish.
of the Earth.
no, we have
That's
not.
what this is.
We have not demanded a physical model, just a model. A model
Yeah,
is a
No, they don't
Oh,
care
good.
about
We got one.
demonstrating things in the lab.
yeah.
They don't care about demonstrating things in the lab.
right. So
And I
I wanted to ask Hanvey about my original question: where is the South Pole in his model? And I mean physical model. Can he point to me where it is?
I've already
Yeah, it's
explained it.
right there.
Like I've already explained it two different ways. I said we could be in a dual pole system where there is an actual ground position beneath both celestial poles, what we call celestial poles in the sky. There could be a GP to those if we're in a dual pole system. And the kaleidoscopic effect of the celestial dome would create that dual pole scenario as well. Now,
That's not what she asked.
I personally lean towards an apparent position. Now, there problems with that? There's going to be problems with any model. It's going to always bring up more questions that can't be answered or have yet to be answered. There's questions with the globe model that can't be answered or have yet
No,
to be answered. Yes, there
That's
are.
false. That's false.
So
Hey
none.
Joe, you guys,
Name one.
you guys let
Name
everybody
one.
fully finish their points, please. Just let's because it's like there's benefits to the open panel because everyone can get in, but then let's just try to keep the audio clean. So Joe, right in following that, can I ask a question? And not intending to go full on into like an entire biblical discussion, but if it is a two pole fixed, like with two fixed poles essentially, and it is interesting how the sky resembles an electric field and so on, a toroidal field with the two rotations. And it's like a universal pattern in nature. Like if you drag like a spoon through water or like a paddle through water, you get the clockwise and counterclockwise vortices. So it's all very interesting, just the way the sky matches electric field patterns. But my question to you is just simply, if it is two poles, like the way you have the North Pole with the GPS and the South Pole with the GPS and so on, does that in any way invalidate the biblical take on things, your biblical take on things, or could it just as equally be a dual pole or a single pole with the apparent southern observations? Are those interchangeable when it comes to, like I said, not necessarily intending to go into a whole biblical discussion, but I'm just wondering, like, does having the two poles, like in any way, is it problematic for the biblical perspective, or do you think it would be the same either way from that angle?
I don't think it's problematic, whether we actually have a dual pole or like an apparent celestial southern pole. I don't think it's problematic for the biblical model either way. No.
Can I ask about the dual pole system? Because I haven't heard you guys talk about that. Maybe you've talked about it before, but I haven't heard it. What is a dual pole system on a flat Earth? That doesn't make sense to me.
So a dual pole would be to where Antarctica actually is a continent, and that 90 degrees south would fall somewhere in the center of Antarctica. And that would be your southern celestial GP of your southern celestial pole. And then your North Pole would be where it is today, with the same thing with Polaris. So you have a GP to the north and a GP to the south that are corresponding to their celestial poles in the sky. Does that make sense?
You have to
Uh,
Pac-Man off one side and Pac-Man in on the other.
so, no, it doesn't make logical sense, Joe. It's a contradiction. The sky can't rotate about Polaris and Sigma Octantis at the same time. That's not logically possible.
If there's a dome, it would bend and manipulate the light in that way. Yes, where we would have
So I'm
straight
sharing it right now, so you can
where
see on my
If
screen.
there's a dome over
if
the
there
Earth,
is there is a celestial dome that has refractive and reflective properties, characteristics, whatever you want to call it, and the light sources that we see in the sky above us are being influenced by those properties, then yes, you would get straight equatorial lines. You would get counterclockwise northern and clockwise southern star trails based on the movement of the lights above
so,
us being manipulated by the celestial dome. Yes.
so what we see is the whole sky rotates around Polaris, and the whole sky rotates around Sigma Octantis. That is a law of contradiction violation. It's logically impossible.
Yeah, so just
You
real
don't-
quick, I have a physical demonstration of this. I'm going to post it in the chat, this little GIF. This is the guy who made this YouTube video. He called it the electric Coriolis effect. I just posted it. So that shows basically he put a magnet underneath a bowl of water, and then he put two little electrodes and then added the field to it. And you get a clockwise and counterclockwise rotation. There's no Pac-Manning. Nothing's Pac-Manning. Those little little iron pepper flakes, are not Pac-Manning anywhere. You have two rotations, and the water is level and planar. So, of course, you can have two rotations over a planar surface. However, there are complexities that could become involved, which is a whole discussion that I don't know if we're going into the entire dual pole type discussions, because, of course, you can have two rotations over a planar surface, but there are certain caveats. For example, the equatorial region, what happens? This is why people always want to say Pac-Man, because if you were to go, what ends up happening with two poles is the meeting place at the middle where the equator is where the fields merge, essentially, where they blend and merge. And so you have the straight stars at the equator, and then they're arcing to the north, going north, arcing to the south, going south. But when you have that straight line of stars, the obvious question everyone asks, well, what happens if you just keep going straight on the equator? Because on a planar Earth, you're not going to loop around unless somebody's going to bring in some kind of Pac-Man or looping concept. But, the globe implies that you would, if you're going straight on the equator, that you go around and around and around. But on a planar surface with two rotations and then the equatorial being straight there, you would not loop around unless, like I said, somebody's going to bring in a Pac-Man thing. So there are caveats and components when you bring a dual pole system into it, in terms of, the equatorial region questions, and there's others as well. I mean, flight paths, distances, there's questions that come up. Also, lastly, I'll just say, if everyone kind of knows the general dual pole, if you're like north of the North Pole and south of the South Pole on the globe, those stars are said to be right next to each other. But on the dual pole, they're like 180 degrees opposite side of the world. So then would you need to have like a reflective or something else involved? So, but Brenda, there's nothing problematic about having two rotations, but there are caveats that come in and additional components that would have to be understood.
So in the image that you posted, the GIF, on the right-hand side, and why can people on the right-hand edge see the stars on the left-hand edge?
Yeah, that was the last point I just made. If you
Why can they see it? Why can they see it?
Yeah, like I said, that was one of the things I brought up. I was giving a general overview because we're just talking about the two rotations in general. If we're going to get all into the entire topic, we could, but I didn't know if we were if you guys just wanted to brush on it or try to dig in.
I must have.
What you're saying is the exact last point, if you were listening, that I was mentioning.
I missed it. Could you explain it to me again? How can a person standing on the right-hand side see stars on the left-hand side? And they're looking to the right, and they can see the stars on the left. Can you explain that? Crickets?
I don't know that anyone mentioned about explaining every single component about a dual pole system right now. Like I'm saying, if we're going to try to get into a whole discussion, we could. I don't know that anyone's claiming anything about it. I think it was brought up because we were talking about the Southern Stars, and Joe was mentioning that, you can have two fixed poles or the one with the apparent position of the South. And what I'm saying is that there's nothing. My point in the moment is to say there's nothing problematic about having two rotations over planar surface. However, there are caveats that are invited in, which is why I mentioned the equatorial region when you go straight on the equator. Then I also mentioned, like, if you went north of the North Pole and south of the South Pole, and so on, you're going to have star fields that are 180 degrees, thousands and thousands of miles away, whereas the globe claims that those are, basically because when you wrap it around the backside of a sphere. So I
You
was
have an answer. So the thing is that a model needs to explain all the data, right? That's what a model does. It explains all the data. And your model here can't explain why people looking to the west can see the stars in the east.
Yeah, I think it's important to distinguish when somebody is making a claim that they're going to stand behind versus just discussing the idea. So because I discuss the idea doesn't mean that I'm making a claim that I have to answer every one of Brenda's curiosities about having a two-pole system. So that's why I mentioned some of the general overviews, the equatorial, the other caveats. I used the word caveat, the other components that come in. And I would probably agree with some of the contentions that you and others have, because I share them in terms of some of the components. So I'm not there may be other people that are going to assert it or say 100%, and if you want to drill them, you can do that. I'm open to discussing it in a general way, but I'm not asserting it in some way that I would have to answer all of your questions at the moment.
Yeah, and when you say, Brenda, when you say that you could see the stars in the east by looking west, you'd have to give specifics of which stars you're looking at and why they would be able to be seen from the west, looking west, and all those. You have to have specifics. You can't just say, explain it all to me the way that I'm hypothetically saying there might be a problem, even though I have no specific example of what I'm saying.
I posted a specific example. I can give you the exact timestamp for it.
All right, cool.
Awesome, dude.
So just a point. Can I make a point? Can I make a point, please? Which is that in science, ideas can be proposed, but they are shot down when they disagree with reality and when they are not logically consistent.
Yeah, that's why we're all here. We all know it's stationary. Our reality is a stationary reality. We need to start with that, Brenda. So science has a big blunder right there. That they assume that there is no lab frame. Everything's used practically with the foundation of the Earth being stationary. That's why we're here. So we're starting with that, Brenda. To comport with science and our reality, we have to start with what we know to be true, which is the Earth isn't moving. Sorry to break it to you, but that's not science. If you have to start with a moving Earth when there is no evidence for that. That's not science. That's assumption. That's just
all right. Enough emotion, please.
Conception. You just have conceptions. You have no foundation of reality. So that's why we're here, because we all know that there's a very good possibility, if not very good reality, that we're stationary.
That's called begging the question.
All right, look,
the logical fallacy.
Brenda's right, but this isn't a college fucking science school club.
No, Brenda is begging the question.
It's a fucking online Discord community in I guess
in which we debate.
Can I make a point to the topic? Can I make a point to the topic?
I'm almost done.
Be careful how much you project, Brenda. You're projecting.
I guess the reach would be better to be inclusive, and some people are going to have different ideas. This isn't like, you see what I'm saying?
No.
Yeah, I get it, dude.
Right, well,
Gio, the question that you had about the idea, like that you have to look this direction and then see those stars. We can, what Joe's saying is we can physically model that. We can put the observer at the location you choose, and then you can look up from there and you'll see all the stuff. Okay, so that's what the argument is.
Well, just to answer, the thing is, perspective real quick. I posted so it's at 33 after the hour. And it's easy to look up because it's on the equinox. People in Australia see the sunrise coming in the morning. They look east. People in South America see the sunset. They look west. And so they're both looking exact opposite directions, seeing the same sun.
Yeah, we've gone over some of that already, and I've looked at different interpretations of it that don't show it exactly the way you're talking about.
And that's how we eliminate ideas when they involve a contradiction. Then the idea is
like a contradiction. We're not moving. The Earth isn't moving. The contradiction is your model has the Earth moving in several different directions. So talk about contradictions. You keep projecting, Brenda. You're really good at that. You're really good at projecting.
That's not a contradiction.
Fucking degenerate, dude.
Can we hold on a second? Can everyone stop the side chat? All right, let's try to do one at a time. Dave said its point. Can I just say real quick? So the factor is that whether okay, everybody in this room is not going to agree, but there are, let's just say if we do 3 models for the moment, we do the general globe model, we have an azimuthal equidistant type of map layout of a planar Earth, and then a dual pole type layout, and so on. If we have those 3, the thing is, of all of those, there are going to be points that some people are going to say that doesn't match reality, and that does. Of all of those, we can get into dark matter with the globe, lack of curvature, lack of motion. We can get into all of that, but the thing is, Brenda, is that there are things that obviously people think don't match reality. And the
That was
thing
gross.
is that
That was really
hold on,
gross.
somebody's hot
Come on.
micing. She's interrupting. Well, who else was hot micing? Please don't hot mic. All right, let me just finish my point. I'll pass the mic. So the thing is that where do we want to go in the conversation? Because the thing is when we were talking about the southern pole being an apparent position or the southern pole being a fixed position, that is just a general layout. And I have suggested arguments. I mean, I haven't been around the entire Earth and checked every GP myself and so on. But from all my understanding, I mean, I have been to the south. I've been to various areas. But in terms of like the GP argument, in terms of the 2 poles, so and to me, it certainly appears as though there are 2 rotations of stars. I think we would all agree with that in general. So that would be some sort of a 2-pole planar Earth. But what the exact map is and how the exact sky works would be the additional components. And lastly, I'll just say, we were told it's a globe. If you believe that, that's fine. You can believe it. It's already the mainstream model. If you're either questioning it or whatever it may, or you don't think it's the globe, there's the Gleason's AE map, which has been, it's in our history, 1800s, and before and so on. So there's that layout. And then the dual pole layouts are the ones, I mean, those are known map projections, but, so if some are considering that there's a third option that may be the actual truth. And lastly, I'm just trying to say that if that's the case, I don't know that anyone in here is going to claim they know every single component of that. And if you want to just be incredulous and say, well, it can't be that because I think the globe has whatever, that's fine. You can have that bias. But you would also have to, I would hope folks could be intellectually honest to say, okay, if it isn't a globe and if it isn't the AE Gleason's map, then there would be a third. And if there is a third, then we're all figuring it out together because we've all been deceived to that level. Again, you may just think it's the globe and just want everyone to go back to that. But I'm just saying, and realistically, that would be the scenario. And I mean, Dave and E1 and many have, insights and considerations for the dual pole, but I don't know that anyone's claiming they have that all figured out. So I just wanted to say that. But yeah.
Hey, Gio, can I respond real quick to you? I wanted to say thank you for hosting, Earth Awakenings. I've still been listening for months and months and months, just mainly from YouTube because I've been super busy with my 4 kids and family and such. I also wanted to thank Joe for popping in. I shot him a text. He popped in, and it's been pretty cool. I did want to say it's interesting too for me to think about maybe the moon map and the dual pole or the apparent position of the celestial stars, north and south, being a possibility. If there's a frozen, circle area that is moving over however many thousands of years, that's also a possibility. But I just love how most of the time you can come in here, people can share their ideas and their thoughts clearly and, bounce stuff around, try to figure out what reality even is. And this server, I think, has helped a lot of people. So thank you. But I got to bow out. Thanks, Joe. Thanks, everybody that popped in that I shot messages to. Much love to everybody.
Break out the knee pads.
See you, Ron Boston. Have a good night, brother.
All right, bro, whatever.
Yeah, bro.
I'm currently showing on my share for the stream. I appreciate the permission, by the way, Gio, so I can show stuff like this. But it's something I've been working on. I shared it in EA the other night, and I'm happy to drop it again. I don't know if you want to play around with it, anybody who's curious, but what it does is it takes data that is available via.
Hold on. I'm going to share. Here, I'm interrupting you. Can I? Okay, if you want to, sure. If you're sharing your screen, because yeah, dude, that was cool what you were working on. I saw like you have basically the AE, the dual pole, and then Shane and Alan made that the one they made as well, the visualization. But yeah, here, just give me a minute while I pull this up, and then while I pull it up, JT, thanks, bro. Much love, man, and yeah, appreciate your, just being you, and that's awesome. We're all doing what we can in terms of the time we have and all of that, and but yeah, appreciate the kind words.
Yeah,
and
dude.
We'll keep it rocking, man. Much love.
My pleasure. And more often than not, we're having a lot of fun in here. That's what I'm enjoying. And knee pads, whoever made that comment, whatever, dude. We're having a good time visiting, sharing ideas, debating, arguing, whatever. We all love each other. We know that. All right, peace.
Just guys razzing guys. I appreciate Gio having the server too, but like making comments like that's just I don't think it's
Dude, you know what's incredible
Yes.
is like, dude, you know
Demonic.
why
It's
it
just
makes more
demonic.
oh, sorry.
Oh, sorry. I was just saying it's just demonic making comments like that.
Yeah.
It's just, but yeah, go ahead.
Yeah. I was going to say with that whole thing, the cool part is I think the projections of the globe are awesome and there's so many of them. They can't do that with my town. I think there's something to be said about that. And I think it's interesting that no matter what globe projection you put under this physical model, I don't care what globe projection, I believe that you can make it look like reality from the observer inside. That's the idea of a kaleidoscope effect, that it could show all of those patterns. So if you'd like to map it this way or that way or this way, it's perfectly fine.
It is actually cool to view it in a way where we could all just actually be respectful to each other, that there's different ways to view what the world is, different lenses by which to see it. And unless someone's saying truth is subjective, for truth to be objective, there is a truth. And obviously that's where the debate comes in and which is the right one. But, well, there's a lot of people in here. I would love to hear Dave and Joe go back and forth because Dave is, in terms of all the work he's done with the dual pole, ICSpin was going to show his presentation. So ideally, I would just make the best use of our time. But go ahead, ICSpin, because you were going to lay this out. I am sharing it now, so if you want to at least give a little bit on this.
Yeah, no problem. Yeah, it's something I've been working on for a little bit, but it just gives you the ability to some basic controls like the time that you want to set it for, and you want to put your particular time zone, right? So then it just makes the conversions easier. It pulls the data directly from time and date, and you can click to certain parts of the year. Like for example, you can click to the next June solstice, equinox, December solstice, and start as a base for that. And it gives you the ability to kind of set like a toggle that you want to click ahead. Say you have it on pause and you want to demonstrate something. You can change it to 15 minutes and just click in 15-minute increments or go forward or backwards. So that's kind of neat. And then when you have it running, you can also speed it up. For whatever purpose. If you want to speed it up really fast to show how quickly sort of the light changes or whatever you're tracking, and you just want to demonstrate something, like obviously you can do some of those things here. It's kind of neat. You can enable different models all the way up to, this is kind of what I have right now, but obviously I'm still trying to work on getting the loading processing power under control. You can see it's kind of herky jerky when you get above 3, but that's kind of the sweet spot, to be honest. You can still have smooth processing on most, I guess, decent machines with a GPU. But anyways, the thing that this kind of brought awareness to me that I never really considered before, and I'll pause it. Like, for example, now everything is mapped on the sphere. This is the globe model, and we can see that up here is Australia, and then we've got the bottom part of Asia, which you can see is clearly all the way up to the Bering Strait, it looks like, is sort of modeled here as well. So everything is based on the data that we get in terms of the lighting. You can see that all of Antarctica is lit up just like it is here on the outside. And so I would challenge people. I mean, there are bugs that are going to be in any software. I think I've got most of the lighting stuff worked out. There is a major issue with this, and I'm not trying, again, Dave, I know this is sort of something that you spend a lot of time on, and I'm not doing this as a mockery or anything. It's honestly a bug that I can't figure out how to fix in the dual pole, where Antarctica
I
is
can
like
see that.
a little hamburger patty, and then
Yeah,
you've
I
got
was like,
an
what's going
entire,
on with the
a
continents here?
lion. I mean, just an enormous
Yeah.
size Australia out here.
Yeah,
So that
something
doesn't
about the
work for the
constraints.
scale. But
It's
for the
using a
most part,
different.
I think I'm sorry. Go ahead, Gia.
Well, the projection it's giving, you're saying it might. Yeah, that looks like, because there's a lot of projections.
It's off. It's not perfect. I've had to spend a lot of time on this one in particular because it's a little bit non-traditional. But yeah, that's why, honestly, Dave, everything else aside, I would appreciate if you'd tell me the things that look wrong with it, as
Sure.
Look over it, just play with it, and I would absolutely 100% speak to you as just a person to
Sure.
You can ask a lot of people.
Can you hear me, by the way?
I really do value the feedback, and I want to make it as true to
Can I be
what
heard
it
right
needs
now?
to be, as what you expect out of it. But the reason that I wanted to show these is there are issues, I think, on the models that aren't the globe that I don't know that a lot of people are aware of. That's another bug I got to fix. but the lighting and it's always represented, I think, fairly on the globe model. And I'd be open ears if there's anything wrong with the way the lighting works. You can change it any day. You can check.
Can you hear me right now? By the way,
we
yeah,
can.
I can hear you
Yeah,
now,
he was
Dave.
just
Yeah, I'm
finishing.
sorry.
oh, now you can. Okay, you could. I was talking before
Yep.
and it wasn't.
No, we could hear
Sorry
you
about
then
that.
too. I think he was
But
just.
I'll
Finishing.
wrap it
Oh,
up.
really?
I'm not going to be long
Oh, I'm
because
sorry.
I want to value you guys' time too. But the lighting again is reflective of what's represented on the data that we have in real life, and the lighting doesn't seem it's represented in the same way. I think as far as the lands are represented, I've yet to find an issue with that. But that's the thing that really makes me slow down and be like, okay, is this something that people would be open eyes to be like, okay, I don't know if light works this way. I know that Die Slow said that I just don't understand light. And again, that's a conversation that I'm willing to have. And I've thought about it since he said that. But little things like this, I brought this up to Nathan Oakley the other day when we were on Worldwide Debates for a little bit. And like the moon right here, for example, is lit, right? But there's light from the sun that's being represented in reality around it. And despite how the sun is seemingly doing weird things here, like I don't understand how the moon is actually lit in a scenario where it's in darkness. I've never thought about this before, but I joked with him that like, does the sun have a laser pointer or is it self-illuminating? And of course, he wouldn't take a position because he was running a live show, among other reasons, I'm sure. But the point is like those are things that I think my model of the thing that I kind of put together does kind of make you think a little bit more in terms of like things that I haven't seen before. Maybe they've always been there, but it's been useful for me to have these kind of like pondering thoughts and present them to you anyways. But that's really all I have to say. So thanks for letting me present. Yeah.
Awesome, man. Yeah,
Yeah, I
sounds
don't know
good.
if you.
I appreciate. Dave wants to get in. Yeah, dude, I appreciate that. Good points, and I like that you've done this. It's cool, and a lot more to discuss. But yeah, go ahead, Dave.
Yeah. Well, yeah, I heard what you were saying. I don't know if you could heard what I was replying to your thing about Australia. Yeah, that's definitely not the continent shape for a lot of these things. Yeah. Maybe mess with the constraints. I don't know. I mean, I like that you put it in that kind of form. The way I made that. If the sun is going around the north for the summer and the south for the winter, then we might expect that if there is ice surrounding us, that would be kind of like the shape of the ice we might expect if that's the the path of the sun. But maybe play with the constraints, widen it out. I mean, a lot of what E1's done is gone straight from the GPS of the sun and straight from the GPS of the stars that he found in the Nautical Almanac. So I don't think that there's some really egregious things that are wrong with what he's put together, like the example that Finky put in the chat about it having to Pac-Man straight over to the right. That's not even what the GPS of the sun would say, according to what I've looked at so far.
No, it's not. My point wasn't about the GPS. My point was about where people look to see the sun. And I posted the day or whatever, the dayandnight.com, the exact time that you can use to reference what I'm talking about.
So you weren't going by the sun's GPS?
No, it's where people look to see the sun.
Oh, so you're talking about an apparent sun position that doesn't match the GP?
Well, people see the sun like from everywhere, right?
Yeah, but you wouldn't see
if I'm where I live and I look up and see the sun's going to have a GP, but I'm going to look a certain direction to see it.
But do you understand how the dual pole layout goes, where it would be going around the blue side of the ball when it gets to the far left or the west, right? When it gets far enough west.
But this is on the equinox.
Right. Even then, it would go far enough out west where you're starting to go into that blue side of the ball, right? So the sun wouldn't be appearing right at the other side where it comes out from the blue side of the ball. It has to either go north or south around that whole area that we call the blue side of the ball. So that area is a little bit of an iffy zone for anybody because no one's out at Point Nemo checking out exactly where the GP of the sun is, even though we have a GP for the sun around that area.
No, but my point is just somebody in South America, like northern part of South America, they look due west and they see the sun.
Yeah.
Somebody in Australia looks due east and sees the sun.
Oh, you're just talking about that it seems like it goes straight down the center, even though the GPs of the sun are never actually on the equinox.
No, listen again. People in at the exact moment, like at the exact same time, somebody in South America looks exactly west. They see the sun. Somebody in Australia looks exactly east, and they see the same sun. How is that
You're
possible?
saying that the sun rises for person as it's setting for the other person in those known areas that we're looking at?
Yeah, and they both see the sun, and they look opposite directions to see it.
You'd have to be in the middle of the blue side of the ball for that to even be possible.
No, this happens at the equinox. I posted it.
Yeah, during the
day and night.
equinox, all people on a meridian can see the sun
No,
rise
you're
in
not
the
even
same
understanding the
direction
model.
and set in the same direction.
I'm understanding the model.
I'm not even talking.
I think you're
No, you're
dismissing
not.
it without actually
Well,
absorbing what I'm
maybe.
saying.
Well, his
Maybe that's
animation.
possible.
Well, the thing is, there's a question. I mean, you have magnetic declination and so on, but even at that, like, how do the magnetic field lines actually flow on the Earth, basically? Because you know how you have like with a two-pole type electric field, they converge at the North Pole, they meet in the middle equatorial, and then they converge at the South Pole. And so when you have like that nature to it, what that does is, if you guys have seen the way electric field is kind of put over that dual pole, it's like the longitude lines are basically curved. Like they're not straight. Like they kind of bow out. You know, they bow to the right, they bow to the left, kind of like a toroidal field, magnetic field. And Dave was posting them earlier, and I'm sure everyone's seen that. So what I'm saying is that the longitude lines, like, I mean, Dave, do you think those longitude lines are curved past on the ground? Now, if they are, then that changes the whole great circle thing. And then Jeremy has the argument that he's talked about leading the target with Coriolis and flying, that maybe they are actually making curved paths along the ground because of the Coriolis kind of component of it all. But with all that aside, or without not going into all that, I'm just saying that so your heading thing, Finky, is if you're using a compass, potentially would be related to how the magnetic field lines are actually mapped on the Earth.
Jill.
So
no
let me
required.
hold on. Let me just say one last thing. Let me say one last thing, then I'm going to pass the mic. So I'm just saying there's that factor. And then lastly, on ICSpin's animation right now, Dave, I think like, even though, yeah, you may not agree with that projection he's got on the dual pole, but I think the idea is kind of displayed there. The way he's animating it right now, it's the last thing I'm going to say, is just when you see the sun, like right now, if you're looking at it, Dave, but the sun kind of comes up over South America, you know, consider it's going west. And then as it loops around, if you consider what east would be, it's like making a right-hand turn, but in terms of west and east. So if west and east are like a set things, you know, the way, well, that's what I'm saying. The globe has longitude lines that are straight, but if they're set, then it's basically making like a 90-degree angle instead of 180. You know, being
well, yeah. There's cardinal directions,
let me respond to this real quick.
Oh, go ahead.
So I picked the equinox and I picked the equator on purpose because on the dual pole, I'm looking at Dave's map right now. On the dual pole, east-west on the equator, it's a perfectly straight line. So you can take people on that line, right, on both sides, and they look opposite directions.
Yeah, with the time and date, I've had issues before with what you posted on that, and then I showed you where the GP of the sun was, and then put it on the dual pole, and it didn't seem to line up with this interpretation with the time and date. It seems like a straw man for the dual pole can be easily rendered from this tool that you're using, because I've found it before, and then I put the sun where you were saying it was setting, and it was actually not in the same position according to this translation of it. So I'll look at the time and date for the sun's GP on Wednesday, March 19th. 2025 at 2300 and see how that lines up with what you're trying to say. But the one you put up before, you put it like the sun was on the right and on the left at the same time, which is confusing. I don't know what you meant by that.
Visual. They look. One person looks east. One person.
By the way,
looks
that's
west.
Pinky talking. I know you thought it was me, but everyone thinks.
No,
so,
I didn't.
So go ahead, Pinky.
I didn't think it was
you.
you.
Didn't? Okay.
I knew it was Pinky. Okay. Yeah, because he was the one that was putting the thing in the chat that doesn't seem to reflect at all what it would have to be, because the sun goes up around the north, and it would have to go all the way around before it even gets to that position. So I didn't understand what you're trying to say.
Well, no, I'm just telling you where people.
Or it has to go all the way around the blue side of the ball before it would be in that position.
I know, but
I'm not even sure what you're saying now.
While it's going around, I don't know. People are looking east. They're looking west. So it's even worse if it's going up.
Are you just talking about directly east and directly west at the equinox? How it goes straight across
at the equator?
Is that what you're trying to say? Right. Yeah, that's one of the things. That's one of the things that I said for my GIF of the sun going around.
They're breaking up for y'all.
So what if full model is correct?
Hold on, Dave. You're roboting pretty bad. So you gotta either restart if your connection's back or connection's going out.
All right. How about now?
Hear you now.
And
Yep.
now, how's it now?
So far,
Yeah.
good.
Okay. I just had to reconnect my Wi-Fi. If I come in from the outside, I have to reconnect with the Wi-Fi if I'm inside. But yeah. So I was saying for the GIF, I need to make a because it does seem to go straight out west, and so if that is the case, and it does actually veer north or south on the equinox, then it would go out much further west before it starts to veer right or left or north or south, and then that's possible because it's in the middle of the blue side of the ball, where all of those GPs for the stars and the sun are in question. I mean, unless we have readings from somebody at Point Nemo up at the sky and verifying that there's parallel star trails from the north and the south on that blue side of the ball, or the sun is right where it's going straight across the full side of the blue side of the ball, even though those GPs can be deceiving if they've wrapped the ball top to the bottom and they just give you some kind of rendering that shows you it's a ball. So a lot of these translations, and even like with any transform that's based on the globe, if it's assuming a globe, then all bets are off on what we're being shown, because if the globe's not real, then we have to take into account that they're showing us something they want us to believe. So if it's zero latitude, it could be like very, 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 very high or above the North Pole in the way that the model looks, even though you wouldn't be able to see it in the south, actually, and that lines up with the 24/7 for the north and the south. That it goes around those two areas perfectly for the dual pole. So it'd really be the GPs from the blue side of the ball that you'd have to be able to somehow confirm objectively to debunk the model, in my opinion.
Yeah, I think you totally brushed past the issue again.
No, I think that you're saying it goes straight out west. Right? You're saying it goes straight out west, and then it comes in straight from the east, which is only possible if it goes around a ball. Is that what you're saying?
No, I'm saying at the exact same time, not different times. It's not like later it shows up in another spot. I'm talking about at one exact moment in time.
Dude,
at one moment in time, it can be seen
from one person in the south.
No,
from what two positions are you talking about? You have to give specifics.
I've said it like 4 times. One point in time, 2 locations.
Okay, so which 2 locations?
Opposite directions.
Which 2 locations specifically?
Dude, it's in the graphic, and I've said it like 4 times.
Okay, well, I have the one here that says that it shows the sun on the left, and it's for Wednesday, March 19th, 2025, right? So even just looking at the one here, if the sun is that far away, right, to the west, right, what are you talking about with someone on the east being able to see that? And what position on the east are you talking about? Because then we'd have to go back and look at all of the other translations that
any of it. Take Australia. Take a north eastern Australia. Which direction do they look? You can see its light, so that you know that they can see the sun. Which direction do they look?
Right. Okay. So this is something I'll have to go and look and see what I can find.
We already know the answer.
Data.
No,
we don't. Know the answer. There was another one that.
Well, hold on, because when the sun rises in Australia on the equinox, we know what direction they see it come from.
Okay.
Due east for all observers on the Earth.
Let me take your data and put it into what I did before to figure out that there might be something apparently going on that's not represented accurately here. Because this is a dual pole transform as well, or not this one, but the idea of the light, even on this one, where it shows that dark area, right, going through the middle. This is inaccurate for what you would see in real life, because we don't have light on the other side of this dark area, of this ball of darkness coming through. It's because it's like a Mercator translation that's showing it that way, right? That we would have light in these other areas.
The light,
it's not accurate already.
Light on here, whatever it says is light, is actually light. And so if it's light, you know that you can see the sun.
Exactly, which is my problem with what any transform makes a GIF for the dual pole with the way the sun and the dark.
It'd be
The
the same on
dark
dual.
ball of
It'd be the same
darkness
on
comes
dual.
through the middle.
If it's light on
Dark
one, it'll be
ball
light
of
on the
the
other one.
dark ball coming through the middle doesn't seem to be what we exactly for the areas, right? So let me just take this data and look at it. We can talk about in the meantime while I look some of these up and figure out some of these apparent things.
Another time. I don't
All
know.
right, so hold on, Dave. You were roboting a little bit at the end there, just so you know.
I'm not.
Yeah, you're a bit delayed.
Okay.
Yeah, you're delayed.
It was
yeah.
fine. Okay, now, right?
You're still kind of roboting. Let me
Should
just
be good now.
All right, just give it like 10 seconds. Let me just
Okay.
post it real quick. So I posted this. Somebody had made this. I just posted it in the chat. It's this like a dual pole type layout. Dave, it looks like a slightly different projection than some of the ones that you and E1 have shown, like the actual how this one. And they did this animation with the sun. And I remember I don't want to put words in Bacon's mouth, but Bacon said something like, "Yeah, like this actually matches."
I made this. Yeah.
This matches the lighting of what the globe model claims, like the general lighting effect. You know, what's light and what's dark at any one time. And so if you're going to place the continents in whatever way you place them, there is when they're light and when they're dark. You know, straight up. Like I don't know, like the data on timeanddate.com might be contested by some like in Antarctica maybe, but in general, I mean, we can track when the day and night are. So I'm just saying when you have that, and so it does end up with this type of a lighting pattern, which I think is pretty cool and beautiful, but it does, like ICSpin was saying, like you have this kind of wraparound effect or caustic effect. And then lastly, like there is even there's the idea that nighttime is like a luminary. You know, that nighttime is not just the absence of light, but it actually is like a luminary itself. You know, like the blue sky is a luminary, the darkness is the black sky is a luminary. You know, well, it may be hard to call it a luminary, but it's a celestial body, or that's more what I should say, a celestial body. That the darkness is a celestial body, the blue sky is a celestial body, the sun is one, the moon is one. So that's another interesting thing to where, you know, like just lastly, I'll say, like, you know, I'm not saying this is the case, but let's say you had the sun or the blue sky took up the whole world, and then you had a black thing that just went within that blue sky. You know what I'm saying? So it changes the whole idea of lighting if you have them as their own actual entities. And there are certain ancient spiritual texts that refer to them as that, you know, the night and day, and then the sun and moon. So I'm just saying, like, that's interesting to consider. But it seems like with these dual pole ones, it does kind of make that like circle of darkness within a field of light. Don't you think? Or
yeah, and I wouldn't know objectively, of course, I wouldn't know if it is or isn't the case, and that's the way, you know, the lighting comes out for a transform from the globe, as well as what it seems like this one, as well as what ICSpin's put together, and maybe that is the case. And I've asked E1, I mean, could we have a coffee cup caustic type lighting going on? And he said, yeah, to a certain degree, but I don't think it would make this patch of darkness go through the middle the same way that he explains the electromagnetism would work with the sun going in between the poles and then having it radiate out because the electromagnetic fields are actually affecting the sunlight. And so maybe that could also be explained with the electromagnetic fields along with the dome or whatever for any kind of coffee cup caustic lighting situation. I don't know. Could you hear me on that? Or not sure? I'm not sure.
Yeah, we heard you. Yeah.
Okay. Okay.
The problem is coffee cup caustic doesn't explain the discrete location. I mean, it okay if we could just see a glowing haze in the horizon, but on the equinox, all observers on a line of longitude see the sun rise due east and set due west at the same moment, like at a discrete location. They don't just see a glow reflecting off the dome like a coffee cup caustic. They see a discrete location for the sun, and that makes it very difficult to try to model on a flat plane because of, number one, how are they all seeing this unified object in one cardinal direction, the same cardinal direction, and then at the same time on this other side of any flat Earth map that you draw, how are they seeing it in the opposite direction?
Well, you do have to admit the blue side of the ball. I mean, just objectively, guys, does it really make a lot of sense that the continents would only be on the one side mostly if it was a spinning ball, an oblate spheroid? I mean, I know you have to use like a perfect ball for the model, but it wouldn't be a perfect ball to begin with. But that just having all the continents on that one side makes it already like a little suspicious that maybe it is the dual pole and they just wrap the ocean back to cover the back. I mean, not to say you have to think that's what it is, but it kind of does physically not make a lot of intuitive sense that all the continents would just be on that one side and we'd have this whole other side with just complete ocean for the physics and the dynamics and everything about a spinning ball. Can you at least admit that even if it is that way, it doesn't make a lot of sense intuitively?
Why would the spinning ball require the continents to be evenly distributed across the Earth?
Yes, Dave.
I have to
I
explain
would
that
say
to you. Come on.
I would say yes, and also the international dateline, which is all like.
But I want to hear the logic behind it, though, Gio. He said yes. I want to hear the logic
Really,
behind it.
does someone really have to explain the
what would
logic
be
of spinning ball that would have like surface like the mass of a you don't get that? I mean, you've heard the argument many times. Why do we have to explain it to you again? Haven't you heard that everything would not only be that there would be evenly distributed, but it would all be like towards the middle of the area a lot more, and it wouldn't be like at all what we would expect to see if it was like being affected by the rotation?
I'm about to drop down, fellas, so I appreciate it. It's been fun. I'll just close with this. Like me personally, I think anybody who would say that there's not problems with every model is being intellectually dishonest. I mean, I'm honest enough to say there are definitely problems with what I'm doing, and I'm trying to work those out. But I don't give up just because there's problems, and nobody who's actually trying to work in science is just going to give up because they have problems. They're going to keep trying to push forward and find answers. But I think it's intellectually honest to say, hey, there's problems with every model. And it's good to come in and discuss and talk about these things. So I'll just finish with that. I appreciate the time you guys gave me, and hopefully we can do it again.
Hey, cool. ICSpin on that one problem that you probably would acknowledge might not seem intuitive, right? About the distribution of the continents with the spinning ball. Is that one of the things that you're talking about?
Uh-huh.
Yeah,
I'm
that's one of the
troubleshooting
things
it right now, but yeah, I am.
Hey, hold on.
You see that would be an intuitive problem, right?
Dave,
Like right here,
say,
right? Like this is what they're calling Australia, and that's what it's calling Antarctica, right? Yep, that's what I'm
No, I'm
acknowledging.
talking about the globe model that things aren't evenly distributed, and we have one side of it all ocean. That doesn't seem like intuitive for what we'd expect, right?
He's talking about the fact that the northern hemisphere has the majority of the land compared to the southern hemisphere, which is why the northern hemisphere is so much more populated than this southern
hemisphere.
No,
I'm talking about the blue side of the ball being all ocean.
Dave, hold on. Can I get it like 20 seconds? I just wanted to you guys can continue, of course, but Joe, if you're still there, Joe, I just want to say, dude, thanks so much for coming by. And yeah, we could set up if you ever want to. Like, I think Run Boston Bear had sent me a DM mentioning, and I was gonna have to read it again, see exactly what he said. But yeah, we could always do like an event. Like we have this open panel show, but we can do events where we can either do like presentations or go through specific just looking at things and doing anything that's involved with sort of like a more controlled type setting, where it's not necessarily everybody jumping in like the kind of open panel style. So I'm just saying, yeah, I mean, anytime, because I actually found your channel, I think way before a lot of other people did. I just through all my, research and everything, I had come across your channel, and I think it was before people, like not too many people knew who you were, and I found it and I was like, dude, this guy's awesome. And this is like years, like a long while ago. And I was bringing your videos up like on this live stream, specifically the ones where you had like the netting and you were showing the bottom up obstruction and then the sunset. Dude, that is awesome work you did. And it was like kind of like back then I was like, oh, it's like I found a gem, like a new channel. This guy is awesome. And yeah, those and we went through those videos like in detail, and showing basically what you were showing, and for a lot of the arguments of like how the sun sets and where you had like the two nettings, and then you had like the light or the laser that was shining on the cart, like it was like a wheeled cart, and then you were wheeling it away. And I think I even took that at one point and I kind of like I cropped it out and I put it next to a like an actual sunset. It was pretty cool to see how similar it looks, and it's such just an awesome like small scale representation of the sunset effect, which so many people have questions about over planar surface. and yeah, like you showed in that, the actual mechanics of it and how that works as well. So anyways, man, no, I just wanted to say, I don't know if we've had too much, I think we've talked a bit, but we haven't had too much time to engage, but I just wanted to say, yeah, man, thanks for coming. And I know it's a little hectic and hard to get in sometimes. But yeah, I'd love to talk to you more about, a lot of these factors, like, yeah, the dual pole, the apparent position, the different layouts and stuff. So, but yeah, I just wanted to say thanks. And, and anytime you want to be a guest and come back and we can either do, some more, either like an event or anything of that sort, always feel free. And yeah, just wanted to say thanks and appreciate you.
Do I have him muted? I can't hear him. Is Joe here?
I just looked now. I think he was in the VC when I was saying all that, so I assume he heard me. But if not, it's all good. I just wanted to say.
Oh, okay.
But
cool. Yeah, I'm sure he'll listen back. I was going to talk. I'd try to talk to him as well. Did he put a link for his latest model in the chat, or does somebody want to repost that?
I don't think he posted anything. He just said, "Look at my YouTube videos."
JT posted his channel, I think. But you can search him up on TikTok or YouTube.
Yeah. I've looked at it
Hanvey.
before.
He's
I didn't know
easy
if there
to
was a
find.
link for something new, because I know there was some new things possibly he was working on since the last time I looked at it.
Yeah, on his TikTok, I think he said there's some stuff you could find. That, like,
Yeah,
you
he
could
sent
put
me
out.
links for that before. I don't know if there was an update.
Dude, it doesn't matter what projection you put underneath this. You can mimic reality physically. It's amazing, dude. It's a kaleidoscope in the sky. You guys were all told this so long ago. The Beatles, I think.
Do you want to repeat what you said, though? New perspective. You're talking about something to do with the oceans.
No, I was just saying that there's that blue side of the ball, where a lot of this stuff is going to be iffy because no one's out in the middle of the ocean there really getting
Pacific Ocean,
objective
you mean?
data.
Like
You
in
mean the
this
Pacific
area?
Ocean?
When you look at the
Hundreds
globe,
of planes,
right?
hundreds of planes, thousands
Yeah,
of
there's
boats.
data showing
Specifically
that
the Pacific.
there's going to be reifications. There's going to be things that make you think you're on a ball with planes flying over those areas seemingly,
Well,
or maybe even
don't
boats.
say don't
But-
speak for us. Speak
but-
for yourself. Like don't.
No, I'm
don't
saying there's
speak
going to
through
be
us.
Well, that area has like what? It has like Hawaii and Tahiti, like
Let him
Bora
get it out,
Bora.
please. Hold on,
Like,
Jake and
I'm not
Gatebreaker. Do you guys
speaking for
mind? I'd like to
anybody.
hear what he's saying.
Yeah, I'm not speaking for anybody. What I was trying to explain before is that one of the things that a lot of us, when we first get into looking at the globe model, we're like, wait, the distribution of the continents and the way it's spinning, and it's supposed to be bulging at the center with the oblate spheroid look. First of all, it's a perfect ball. It's not really a perfect ball. It's supposed to be an oblate spheroid, so we have to take that into account. But we use the ball as just like an easier way of representing it, which isn't understandable. But as far as the distribution of the continents and the way they show the globe, when you turn the globe, you have one side of the globe is all ocean, right? Now that doesn't seem intuitive if it's spinning and the continents would be distributed somehow because of the spinning, So it doesn't seem like that. Not to say it debunks the model, but it doesn't seem like it's one of those things I think even a baller might be like, that doesn't really make a lot of sense if I'm being honest.
but you understand that under our model, the gravity is much stronger than the centrifugal force that would be trying to push anything towards the equator, so to speak, right? Like it would be like me taking a powerful magnet and then sticking an iron filing to it. Like say I made a magnet, I carved out a spherical magnet, and I put an iron filing on it. That's like a neodymium powerful magnet, and then I slowly spin that, or I spin it up to the speed where it has the equivalent ratio of the force of the magnet to the centrifugal force, and expecting that iron filing to move, and that iron filing would not move from the spin. The spin would not affect it at all.
Okay, I'd have to see what you're talking about. Does that satisfy anybody else that might be critical in the same way I'm talking about?
Like you understand, if you do the math on what the centrifugal force is as a result of the spin, right? And obviously it would be strongest at the equator. It only works out to like reducing a 200-pound person's weight by just a few ounces.
So another measurement that ends up being negligible that we have to just accept it as
Not that it's negligible. This is the exact reason why, if you're trading gold, for example, you always have to use a test mass to if you're not using a mass scale, if you're just using a force scale, which is what most jewelers use, that's why they have to depend on those calibration masses, because otherwise you could be doing arbitrage and losing money, right? Because your scale
All right,
at
so
your scale at the equator would be reading differently than your scale in like, in Norway, right?
Yeah,
Like,
an electromagnetic field would also answer for that.
Can I just say, okay, so getting into the whole weight change of latitude thing, like, and centrifugal force, if you guys, but I was just gonna say, Dave, like, so I hear what you're saying. I would agree. The blue side of the ball it's interesting to consider how the dual pole plays into that, to say the least, for sure, because that's the thing that's in contention. And we have this ball that basically is half a ball. It's half a ball of continents, and then the rest ocean. And so the idea that it's actually the Pacific Rim that's around the outside and not Antarctica is very interesting. And they would invert it like that too. Of course, they'd make a different rim around the outside and try to sell a false flat Earth. If that's the case, that Antarctica is actually a continent, which I've never been there, but I am strongly leaning towards that being the case in general. But I'm still open because I haven't mapped the whole Earth. But Dave, what was I going to say? So, yeah, the blue side of the ball. However, I was just going to say with the continents thing, there could be a rebuttal where they could just say that the water levels are different and there is actually a bunch of land under the Pacific Ocean. It's just underwater right now. What do you think of that? As like that's one way to rebut it.
I wasn't even trying to say it's a debunk. I was just saying that just visually and just thinking about the way physics, would intuitively seem to work if it's a spinning ball. We all kind of like, that's a point that is intriguing when you first start getting the flat Earth, proofs or whatever. Like why is it the land distributed this way if it's supposed to be like a bulge at the center because of the spin?
Can I ask you a basic question? It's sort of something that only dawned on me throughout the process of building this. Even in both models, like if you look in your model here, and I don't expect you to have all the questions for your model. I know it's a work in progress, but even the Gleason map, like I said earlier, I kind of joked with Oakley that the sun must have a laser pointer or it's self-illuminating, right? Like how does the moon specifically receive light when it's in darkness? Like, have you ever thought? Because I had never considered this until I actually looked at this.
You mean even for the globe model? For the globe model,
no, the globe model, I can, and for the globe model, I have an explanation. It's because the moon is lit by the sun, and it's due to the scale of the bodies that are involved, right? The sun and the moon are clearly represented here for demonstration purposes. The moon's like right here, and the sun's here, but it's way drastically different in our galaxy. Like the moon would be way over to the left, and the moon would be somewhere. I think I said the moon by accident. The sun would be way the hell over there, and the moon would still be kind of like way the hell over there. But the sun would have direct line of sight to light it. Even on the dark side of the moon, or on the dark side of the Earth, we'd be able to see even right here. Let's say if the moon was right here, which I still think is drastically less than what it actually is in reality. Obviously, again, doing this for demonstration purposes, but the point is that there is an explanation for the globe that I'm aware of, and I don't want to say that. I don't want to sit here and say like, oh, we have one. What's your explanation? Because that was not my point in bringing this up. It was just a critical thinking thing that I had never had any of this cross my mind. That like, well, how the hell does the moon light up in the darkness in a very specific pattern that we know takes place? We could go look at this exact moment in time up here, EST, right? 7/15/2026. If anybody is crafty in the chat and is bored, at 11:02 p.m., go to timeanddate.com and you can verify that all of these things, according to what was recorded on them, at least, what took place. My question is, like,
are you saying
if that's in darkness and this is in sunlight, then how is this lit up if it's not self-illuminating?
Well, I was asking. First of all, I have a couple questions. For the AE map, are you saying the sun wouldn't be able to align with the moon, or are you just saying because the moon's in darkness, it doesn't seem like it would be aligning with giving the moon any kind of brightness?
And again, I just paused it randomly, but obviously this pattern doesn't make a whole lot of sense. Number one, and that's neither here nor there. But like that aside, I do have a problem with understanding how this is in darkness. Like the moon has to be at a drastically different elevation, maybe, where the sun is somehow lighting that, but also creating this pattern. It creates kind of logic, like it just kind of wrecks
Yeah.
my brain. You know what I mean?
Well,
Like
I
I could
know
probably
that
sit
I've
down and be
asked.
like, yeah.
Well, I've asked E1 about this before, as far as like the moon. Is it reflecting the sun's light, or what's going on? And his interpretation, at least the least of what I'll say, he was saying, is that the moon is charged by the sun. Right. So it
Okay.
may be having its own light, but it's charged, and it has a certain amount of charge that it gets when it gets close to the sun, and then, whether that it continues on without it having to be directly lit by the sun and all that, or other questions.
Like those
Yeah, I mean,
Halloween
I
costumes that
just
we
say, I
had
mean,
as kids, right?
well,
Yeah, I guess so.
this whole question though would be really the case on any planar Earth, because if you have like a full moon in the night, how is there so much light that's illuminating the moon but not illuminating the ground if the lights are more local? So I mean that's an issue no matter what. And I mean obviously many people think the moon is its own light, and things like the Bible and other spiritual texts that refer to it as its own light, and then the whole cold moonlight thing as well. So I think I don't know if there's even very many people that have a planar stationary Earth that would say it's reflecting the sun's light. I don't even know if there's any really that even say that, but I can't speak for everyone. So yeah, I mean, the moon would be self-illuminating, although it could still have to do with, like I've mentioned, like the idea of UV light. So like UV light travels a lot further, and it's obviously non-visible, but it travels a lot further than visible light. And like with crystals, like you can apply UV light to crystals and they will fluoresce. So that is another interesting idea that I've mentioned, where I'm not saying it is the case for sure, but let's say the moon was receiving the UV radiation from the sun, but not the visible, just the
Right.
UV, and that UV causes a fluorescence in a potentially parallel way to the way that crystals will fluoresce if you apply UV to them. So that's a UV light. So that's another kind of idea. And then lastly, I'll just say,
We have ways to detect UV though in
let me just say
species.
let me say the very last thing, which is also, like, if night is its own kind of entity, then the night might be actually blocking the sun rather than being an absence of sun. There's a whole nother angle, but yeah, go ahead.
Well, I don't know what the comment was he was saying, but I have something with your model. Actually, I see Spin looking at this. You have the sun kind of like looking. I know you can't really scale it out to be as far away as they say the sun actually is, but with the sun being so far away, one of the comments that a lot of us seem to think might not work the way the heliocentric model requires is that for the sun to have enough power and light to get to the Earth is such a small little tiny dot compared to the size of the sun and the distance from the sun, that you might expect that anywhere on Earth, because like nighttime is basically just the blockage of the sun, right? Like that's the idea, that it's just a shadow. Like anytime night it happens, it's because the sky is being shadowed by the Earth. So it seems like, if you were to draw it out to scale somehow, that if the sun's reaching us from that distance, the magnitude would have to be so wide and so spread out that we might see like a hint of the sun in the sky to our left and our right, to our peripheral area, if all that's really blocking the sun is our little tiny planet. Does that make sense? How can our little tiny planet block out all of the sunlight from what we see in the midnight sky?
It's making
Because
sense.
the sun would have to reflect off of something for you to see it. You can't see light unless it reflects off something, right? So the fact that there might be sun rays streaking to the outside of us when we look in the night sky, it's meaningless because it has nothing to reflect off of, right?
What are the stars
That's
reflecting off? What are the stars reflecting off? Because we see all
Like
that
you
light.
can't see like
they have their own. They're their own suns, right? They have their own lights. There's a theory, right?
like if you have a dim light, and you have to use a dim light because if you have a bright light, it can light up the atmosphere, right? That's how you can see the beam of a powerful flashlight. But if you have like a regular flashlight, you can't see the beam traversing the open space, right? You don't see the light until it casts a shadow on something, right? Only until it's powerful enough to illuminate the atmosphere itself that you're able to see the beam.
That's one possible type answer. But you know what I'm saying about, like, intuitively, this little tiny planet blocking out all of what any apparent light from the sun. Like, it's pitch dark in the sky.
The
We don't
Earth's
see
shadow, dude.
we don't see any ambient as Earth's shadow blocking out everything.
Dude, and they
360.
tell you the exact distance. Dude, Dave, I've looked into this. They tell you the exact distance the Earth's shadow extends to and all this stuff. You shouldn't even be able to see the moon, dude.
What? No, the moon is 250,000 miles away and it's off the axis.
What do you
Occasionally it
mean you
wanders
shouldn't be
into
able to see the moon?
occasionally it will wander into the Earth's shadow when we call that a lunar eclipse. They happen occasionally.
Anyway, my point was that it does seem like if you're being like ultra skeptical, ICSpin, your sun being a little bit local kind of like hides that idea. Not to say you intentionally did it, but having the sun be local kind of makes it seem a little more plausible than it might be with what I was talking about with this distance so far away. It's kind of like when we talk about how the sun changes just a few angles in the sky and we feel a huge amount of heat difference. But proportionally, for the sun being that far away and reaching us, you wouldn't expect that much of a difference, because it's just a few angles in the sky compared to 93 million miles. So there's some of these things that don't intuitively add up with the heliocentric model in this way. And you'd think maybe a little bit of ambient light, like the sun, like the idea that the Earth blocks out any notice of any kind of sun coming from the back of us is a little bit of a stretch of the imagination just to accept it.
Why is it a stretch? I mean, what do you expect? What do you expect it to illuminate?
If you don't get what I mean, then I'm not going to explain it any further.
I agree, but let's
mean,
let
because
hold on,
Well,
Ness. You could have some
Yeah.
awareness. He was obviously talking to ICSpin. Please relax. I don't know if you just got back and just want to
It's
yell at
fine.
people.
I think I might mimic what he was going to say in a slightly more polite way. But he the idea is like maybe atmospheric refraction could cause like some bleed over from the sunlight. I would imagine, but like short of that, like are you talking about something different? Like why isn't there
Well,
light?
I'm not saying that I'm not saying that it technically. I'm not even saying it wouldn't technically work, even though it might not, because we can't really scale it anyway. But intuitively, it's kind of like the idea that our little tiny planet, scaled wise, with the sun's being a million times bigger and that far away, and it's reaching us, that we wouldn't see some bleed over, that our little planet's blocking out all the sunlight to cause a pitch black night is a little bit unintuitive seeming, at least. That's all I'm saying.
And one thing that I would mention, and I'll let others talk, but the other thing, I was going over this earlier with some other people in here about Saturn. Once every 15 years, there's a moon called Titan that will cast a shadow onto Saturn. It's one of Saturn's like many moons. There's like 70 moons or something according to the documentation. But the point is, the shadow casts onto Saturn, and we're able to kind of trace where the sun is, and the math makes sense. The direction that we see the sun when we're actually there was a live stream that I've referred to based on this observation that I put forward in this room, that Red's Rhetoric and a guy by the name of Mike from the Drunk Debunk Show. Sometimes he'll be on this server called the Crunk Debunk Show, but that's the guy that I'm talking about. And they did a live stream for like 6 hours and then basically in the middle of the night. And so my point is that like we can see phenomenon like this, like for example, the Titan shadow, and I'll post it here again in a minute when I get done talking. It's not a perfect lit moon of Titan. It's almost like if we were looking at an almost full moon from our moon, right? Like how it's like it's missing part of it. There's some of it in shadow, and we can explain that shadow based on our model. But we can also look at other planets, regardless of your thoughts about the planets. But we can look at other bodies and be like, okay, this is another good demonstration of what we see here locally and what we can sort of piece together based on our perspective. We're not obviously floating around the planet to look at it, but we can look at some other planets and say, hey, this is what we're able to, first of all, we're able to predict this 15 years, like literally to almost the millisecond. And don't quote me on that. I know it's a very small amount of time that they're able to predict when this will start to take place. And we're able to model it, which I actually did it live today. I went into Stellarium and I showed it Design Act, who I've seen here in the chat a little bit here and there. He'll deny that it was anything worthy of looking at, but I got it pretty damn close, and I did a blink test, and everything matched up with what we saw in reality. And so I would say that there are other explanations that not to just write it off because it doesn't make intuitive sense, because we can look at things in our reality that we are able to measure with telescopes, do a live stream on YouTube at this day and age, and predict it based on a model that literally has no skin in the game as far as it goes when it comes to like doing a live observation. that obviously nothing could really be planned around to like try and manipulate a model or something. We just go and look at what the model says it should have been, and then we just look at what it was, right? And we can kind of
A
draw.
good
Hey,
example of
I got a
that.
question. I got, hold on, I got a question. Real quick. But
Oh my
since I was
gosh.
going
Let
back
new
and forth
perspective
with
respond.
ICSpin, yeah, just real
Yeah.
quick on that. Just because since you're a little bit more intellectually honest than other ballers that we've talked to, can you at least admit that when we have cycles that they model by reverse engineering? I mean, the only way to get the model is to reverse engineer what we observe, right? And these observed, the Sero cycles are all figured out with the stationary Earth. That's what they still use today. And so I'm saying, can we stop using prediction as if it's like exclusive to the globe model?
Can we
It's
stop
just,
using
it's
the
just
word
cycles.
stationary Earth as if it's
Cycles.
exclusive
Let
to
me
flat
answer.
Earth?
Don't
Come on,
jump down his
stop,
throat. He was
Gatebreaker.
asking
Don't
honestly.
troll me in the middle of this. This
That's
is
not
like
a troll.
one of those things. Well, you can call it what you want. I'm just saying it's one of those things
That's the whole
that
point
we
of
have
what you were
predictive
saying.
power.
Bro,
Not
you
predictive
just keep
power. If it's
reacting like
cyclical.
an animal every time I
Look,
speak, dude. Whatever,
Gatebreaker.
dude.
Yeah, because you're an animal coming in. That's what you
whatever,
sound
dude.
like to everybody. That's all you do.
Something I said triggered you.
Well, I
It
wonder
must
why.
have been
I wonder why
the
I react the
fallacy
way I
of
react
linking
to
the
you.
word stationary to flat Earth. Guess what? There could be a stationary globe too. Laugh about it, bud.
Hey,
Yeah,
Gabe,
you're laughable. That's all you are.
Gatebreaker, if you could try not to interrupt people, let's just
Yeah, dude. It's just like
Yeah, let him
come
have
in
a
with
say,
some
dude.
couth. Come in with some couth. I'll respond with some couth.
All right, can we let
And
Dave? Can we let Dave finish, and then Lion
yeah,
wants and ICSpin might want to get in. Let's let Dave and New Perspective finish, and then Lion's next. Go ahead.
it's just one of those things that since you're a little bit more intellectually honest, when you say predictive power, if it's cyclical, it's reverse engineered because we know the cycles. There's Sero cycles. These things were already determined, even though we may have particularly better instruments to give more specific readings. It's all based on those cycles. So I think a lot of globers talk about it having predictive power as if that's exclusive to the globe model, and it's not if it's cyclical.
I think I hear what you're saying, and I'm taking it on board. And you gave me an idea to look at what the serocycles are and what the heliocentric models predictions are, and draw a comparison. There may be someone better in the audience that actually can respond to this immediately, but I do know that the heliocentric model says that we can make predictions that are a lot more precise than the Saros cycles. I think the Saros cycles, as far as I understand, the precision is something like maybe to the day or to the several days. Don't correct me in the audience, but I know that it's not literally to a very, very small amount of increment of time like we can do for the globe model. And we can predict certain things like the actual path of totality within a very small margin that changes over the course of several decades, as far as I understand, again. But I will look into this. That's a good question. And I do think that having predictive power based on what your model predicts and what other models sort of claim to predict, but can't get it to the same caliber, I would say. I think that is a substantial distinction that people should consider when deciding what shape of the Earth they think it is.
Hey, kid, hold on. Okay, Dave, I know, Dave, if you feel like you still want to do a one-on-one, and then Lion, can I just say though real quick, if Lion wants to get in or however you guys want to do it, but can I just, I just had a quick analogy come to my head that I wanted to say. So the thing is, ICSpin with like with the timing and the cyclical nature, I'm just going to give a quick analogy. Let's say at 2 a.m. every night, something smashes into your wall. Every night, 2 a.m. And it's in the middle of the night. You just boom. You can set up cameras. You can hear it, etc. Then, well, let's say the camera doesn't give you the visual, but let's just say you can hear it or whatever. Then you could have a theory and say, I think Superman is running into the wall every night at 2 a.m. And I could be like, I think Batman's running into the wall every day at 2 a.m. The thing that's the same is that it happens at 2 a.m. You have an interpretation of Superman. I have an interpretation of Batman. And we could argue all day. And the analogy kind of works because, like, if it's nighttime, you can't see it, so it just happens. You could kind of link that to, like, we don't really know we can't go up there and touch the things in the sky or, like, touch their mechanics. So I'm just saying that you can have the same phenomenon, but then you can interpret a model put upon it. But if you use the cyclical nature or the fact that it happened at 2 a.m. to say, because it's like affirming the consequent, to say that's the thing that proves it's Superman, or because I could say the same thing, well, that's the thing that proves it's Batman. You know what I'm saying? So I don't know if the analogy worked perfectly, but I'm just saying there's a way in which like the phenomenon are happening, the cycles, the sunrises, everything's happening. And then it's what model you're putting onto that And then if you're going to use that to bolster your model, then you're really only using like a cyclical thing to potentially boost, a bias, and then that gets into whether it's exclusive or not.
That was a
and the fact
great
that
analogy, dude.
absolutely, and the fact that they use it so as like such a proof, like it's got predictive power when it really is just cyclical, and to be able to admit that gives a baller a lot more respect from people that are talking to them, rather than they're just like claiming that there's this predictive power when we all know it's cyclical. It has to be reverse engineered to even get the model to begin with.
But the Saros cycle is quite accurate in timing, but is not accurate in where the eclipse will occur.
It's not
Just to be
true.
clear,
Hold on.
Go ahead, Lion.
That's a different conversation, dude.
It's not
Shift
true. They use
cycles are.
they use the same thing from
Go
before.
ahead, Lion.
To predict when it occurs, not where it occurs.
let me, because then I start getting loud and I'm the
that's
bad guy, bro.
interpretation based
I'm
as
just
well.
trying
Go
to
ahead,
get in,
Lion.
dude. I'm just trying to
Incorrect
get in,
again,
dude.
and you know
Lion.
there's more
I'm
than
just
one
trying to
Saros
get
And
in,
cycle.
that's
dude.
the Lion's been trying to
Yo,
get in. We don't need your trolling right now. Come on, go
Oh,
ahead,
you
Lion.
don't need my
so
comments because you want to ignore them, right? I got it.
Yeah, you're definitely
to add to
ignorable.
what you
Go
guys are
ahead,
saying,
Lion.
this is
Yeah,
not what
because I'm
I
telling the
wanted to get
truth, and
into.
you guys
All right,
want to
guys,
just ignore it. Right?
everybody just stop so we don't have to mute anyone. Okay, NASA Shill, you did bring up a point. Lion is suggesting it's not exactly on the topic. It is an interesting point. We could do it next. Let's just do that, okay? Because you're
Totally on topic.
because you're talking about
I did.
that gets into distances and maps and positioning, but let's just set that aside for a moment.
Yeah.
I hear we're not going to dismiss your point entirely, but let's not just go into an over talking thing.
Let Lion go.
Yeah, go ahead, Lion.
Thank you. No, I did want to get into the moon shadow, but just since you guys brought this up, the globe model in modern times has the benefit, right, of thousands of years of habitual observations of cyclical patterns, right? Ephemeris data going back to the Greeks, the Babylonians, the Chaldeans, the Hindus. They had the data, right? The ancient astronomers understood the sky, right? That's only been rivaled in modern times. It's only been surpassed by seconds regarding their predictability. Not a big deal when you have literally thousands of years of ephemeris data that then now helps you, surpass the Chaldeans by seconds. Little golf clap for you guys. Little golf clap. Now, going back to the moon, right? The moon shadow, right? You guys say that according to the Eratosthenes experiment, you have to presuppose parallel light rays reaching the Earth because the sun's so far away that even though light's supposed to be radio, it's so far away, right? By the time it gets to Earth, it's basically parallel. Yet, you can't explain the penumbra during the solar eclipse, right? The moon's supposed to be around 2,000 miles in diameter, right? The moon shadow, right, during totality on Earth is around 300 miles in diameter, right? That means that light is not coming towards the Earth parallel. There's a problem there. There's an inconsistency in your model. Light must be converging to have the shadow shrink from 2,100 miles to 300 miles in diameter, the totality on Earth. And nobody's been able to explain that except, your little models that you try to model out the distance of the moon. That
You
doesn't
can
help
do
you,
it.
dude. Go ahead.
You can do it in Blender. First of all, the size of the moon's shadow. You can do it in Blender. You model a light source the size of the sun at the distance to the moon, the size of the moon, and its distance to the Earth, and you can measure the penumbra and the umbra, and it will work not only for an object that's the size of a softball and a golf ball with a light source that's like the size of whatever, but it'll also work for the sun relationship.
No,
Number
but you don't
two,
understand that it's either light is coming in parallel or it's not. It's one or the other. You can't have your
yeah, it's
cake
not.
and eat
It's
it too.
not. It's
So
not.
in order to have a 300-mile diameter totality on Earth that you can predict reliably, right? You have to have converging light rays. There's no other way.
Yeah, but
So
you
either you
understand
have
that because the sun is so much bigger than the Earth.
hold on. Either you have parallel light rays or you don't. Which is it?
We don't. They're not
They're not
parallel.
technically
You don't.
perfectly
Thank you.
They're
parallel.
not
No.
parallel.
Thank you.
They
Yep.
are parallel.
Because the sun is bigger than the Earth, and it's emitting light in all directions. You're going to have rays coming that aren't perfectly parallel from the sun, right?
But even if they were parallel, it's still the eclipse would still work. So I think your statement that it's required is false.
You wouldn't
No,
have
dude, I'm
you
not.
wouldn't
Dude,
have a
that's not
umbra.
my
You
argument.
wouldn't
Dude,
have a
hold on.
penumbra
He's not
though.
even following what I'm saying, dude. I'm talking about the totality, right? The diameter of the shadow of the totality. Not saying the eclipse wouldn't work. I'm saying that
Yeah,
light
that's the
must be
umbra.
converging, which is a fundamental flaw in your model because you absolutely require parallel light rays.
Yeah, here, can I just post a visual image real quick? I'm going to post 2 images in the chat. So here's the first one. This somebody made, whatever, it just shows the idea. The thing is, the proportions are wrong on that because what it would really be is like the only part of the light that's leaving the sun is almost like a straight wall, basically, because it's so huge. The diameter or the radius is so massive. So the proportions on that are not particularly right. But nonetheless, the second image here I'm going to post is basically just it's not zoomed.
To be fair,
Let me just finish. Hold on. It's that zoomed in, but the idea would be like I think I must have drawn that on there. Moon kind of thing. So if you had parallel light rays, if I'm understanding the point Line's making, then those parallel light rays would only cast a shadow that's the same size as the actual moon, and that's what's required for Eratosthenes, your parallel light rays, etc. But that's not the way the actual shadows work.
Similar to what Titan, similar
you
to like
understand
how Titan does to Saturn. You know how you guys show Titan and Saturn? That's what you would
I showed that.
expect.
You understand that these
for all intents and
diagrams
purposes,
posted a good graphic
actually,
showing the
I'm going to
parallels
let
of
NASA
light.
speak. NASA's better on this topic than I am.
You understand these drawings are not to scale, right?
What Gio just said.
Yeah, I said that, but the thing is, it doesn't really matter because the second part I posted, like whatever you think the sun is, if it's coming parallel, it's coming parallel. Whether you think it's a XYZ about it. So the second one I posted, that's why it shows the idea of the parallel rays allegedly hitting the Earth and then the moon, and parallel is parallel. You can get a bigger or smaller shadow if you angle the light. Like if you have like a really wide fluorescent light that's like it also has one of those plastic covers on it, so it's kind of the light is diffused, but therefore it's a very wide, let's say 5-foot long light source, and then you put like a cell phone or your hand or whatever like just above the table, you can get your shadow to go bigger and smaller as you move your hand up and down because the light is coming in from the angles, almost like corpuscular rays, but the opposite. But the lights are coming in at all angles because the light's larger. So in theory, you could have that. But the thing is, in the globe model, they do claim the sun is huge, but the key thing is that they claim that the light rays are all coming in parallel. So you're not getting any angled light, which would be required to make the shadow of the eclipse smaller on the Earth than the actual diameter of the moon.
But no one says that they come in perfectly parallel, though, right? They're not perfectly parallel. For all practical purposes, they're parallel. But Bull Knight's a good demonstration of that, right? Just like the light source, like what you're talking about, Gio. If the light source is bigger than the object, then the shadow will always that the object is cast by the shadow cast by the object will always be smaller than the original object when the light source is bigger. If the light source is smaller, then the shadow will be bigger, right? That's how you're able to, and you can do the math on the umbra and penumbra based on the size of the light source and the size of the object that's casting the shadow, and it will always follow that relationship. And that in itself tells you that like the light rays that are coming off that light source that's larger are not perfectly parallel, right? That's how they're able to cast an umbra and a penumbra.
Thank you. Yeah, so it's not parallel. All right.
It's
cool.
pretty much
For all
parallel
intents and purposes,
with a half
Yo,
degree.
somebody get that.
Hold on a
Somebody
second.
record that.
Let me draw an analogy, right? You know Polaris. Hold on a second. Do you know Lion? Do you know how far away Polaris is?
No idea how far Polaris is, dude.
If I remember correctly,
Do
it's
you
like
know how
something
far
like
it is?
430. Yeah, it's like 430 light years, I think. Let me check. Let me double check my map. Polaris distance to Earth.
Here, while you do that, hold on. Let me just get like let me get like
447 light years. Do you think that the light rays that come from Polaris are parallel?
Well, that's what you guys say.
What you're talking about? You're talking about point light sources like the stars, the sun.
Yeah, but we receive the light from them, right? Like these point light sources, we receive the light.
It's not even the close. Yeah, it's not even the same.
Hey, let me hold on. Let me get like 10 seconds, dude. I'm posting this right now. This is the thing. The whole parallel question. Okay, I put 2 yellow lines in there, and then I put red X's and pointed to the lines. That's the thing. So if you're gonna say like, it's like the fluorescent light where it's wider and it's making these angled shadows, fine, let's roll with that. And then if you put a moon there, that's what you would need. You need those yellow line general angles to make the shadow smaller. Okay, cool. Let's roll with that. Now you definitely don't have parallel light rays hitting the Earth. Eratosthenes is out the window. All your entire extrapolations of the celestial sphere are out the window. Becomes a
No,
huge
You have
issue.
to see it. You have to
no,
see it
the
to
sun
scale.
has its size.
I'm gonna
We know
post
the
here. I'll
size.
post
The
something
point
to
is
scale.
You could.
there's
The
literally
sun has
nothing
the
that can
sun.
give us light that is exactly parallel. It's immeasurable. We can't measure non-parallel rays from Polaris. Like that's absurd, right? But the point is, it's like the way that the model works, like, and the way that the distribution of light works over that distance, they are, for all intents and purposes, to any measurable scale, infinitesimally like small of a diversion from parallel. Like it would be immeasurable. But there is some diversion from that parallel fact, I guess. But the point is that if Polaris is 437 light years away, 447, excuse me, and you can look it up and say, to be exactly precise, is it 447 light years? If it says yes, it's exactly precise, then I stand corrected. But if you look at the sun is like 8 light minutes away. Drastically different, right? Drastically different scale. And we're talking about like for all intents and purposes, they are measured parallel unless you go to the very, very smallest degree. I don't even know that we have precise enough instruments to measure them not being parallel. Maybe we do, but like for all intents and purposes, if we're looking at a demonstration with our eyes, for example, the drone that goes up above like the pole, like the wooden poles. You guys might have seen it where it's like at a park or something. Someone takes a drone up and they look down, and all the poles are parallel. But at first, they looked like they weren't, and like it's just a demonstration of how perspective works. But my point is, like at scale, like just like NASA said, it's very hard to see things that are not parallel when we're talking about the sun and things beyond that.
I don't know why you brought like the whole like where the light poles.
Polaris?
I mean the street poles, right? They look like they're converging,
They
right?
look like they're converging, right?
That's
You can
but
see the light shining through
yeah,
them, but then when you go up above, you see that the light is parallel. The way
like
that the shadows are cast.
like crepuscular rays and stuff. But that's just
Just get rays.
illusory. That's due to perspective, right?
Compressed phase.
When it comes to the shadow of the sun, the moon, right, during a solar eclipse, you don't
That is
you can
because the
actually
sun has a
measure the
definite
diameter
arc.
of the shadow and know that it's actually around 300 miles, right? And you guys claim that the moon's supposed to be 2100 miles, or if the light is coming in parallel, right, it should be at least close to 2100 miles, dude. Not even
You have
close
a
to
source?
2100 miles.
No,
It's
it's
like
not.
300 miles in diameter, dude. You're saying, oh, it's a nominal
Don't get
amount.
excited.
It's
No,
negligible.
don't get excited.
It's just
Lion.
a tiny little bit. You know, the
If you do
light's
the math,
basically parallel. If it was basically parallel, right, then it should be closer to 2100 miles in diameter. Yet it's not.
if you
So
do the math,
Let me
the
hold on.
light is
Let me
coming in
speak real
parallel
quick,
or it's
NASA.
not. You guys always try to reduce it. Oh, well, you know, it's a nominal amount. It's insignificant.
Look,
So
hey,
here's what
don't
you could
let
do.
one sec, Jake. This is what I want you to do, Lion. I don't want you to get excited. I think you're on the road, but like if you have some time, look into what you're saying right now about this diameter discrepancy and find me and send it to me because I want to look into it. Because I think one of us is misunderstanding it. And I'm not going to say it's you. It could be me, but I want to understand more about what your claim actually is when you say the way that the shadow is cast is that drastically different, because there's something that either one of us needs to take a closer look at, and I'm happy to do that with you, because I've never heard that, and the only things I've ever seen from a lunar eclipse, I don't know if you've ever seen the measure of the universe by Terrence Tao, who's an astronomer. I want to say out of a California. I can't. Someone can correct me, but very, very smart astrophysicist that has
Solar
done,
eclipse, not lunar eclipse, dude. Solar eclipse.
So, okay. Well, I'm thinking specifically about the solar eclipse, or lunar eclipse. Excuse me. So, just hit me up in a DM or find me on one of the
Well,
forums.
dude, we don't have, dude. We can talk about it right now. You don't, dude. It's right.
I need
dude.
to look at what you're saying. That's a drastic.
Yeah, it's in,
difference,
dude.
by the
I'll
way.
post, dude. Yeah, I'll post it again,
Okay,
bro.
post it. I thought you were on the road. I was trying not to like.
No, I'm
take
parked
you
right
off
now.
what
I'm
you're
parked.
doing. Okay,
I'm getting ready to get.
But
yeah,
Jake, sorry. I think I interrupted Jake and someone else.
But hold on. So here, look at the image, dude. Granted, this isn't the scale, right? You can scale it out.
You can't say
Regardless
granted
if you
it's not to scale. It needs to be to scale.
regardless if you scale it out, right? If you put the sun 93 million miles away from the Earth, right? Now this is the wrong one. The wrong one, dude.
Yeah,
the
you
light
hit
hits the
the
moon in your
This
example.
is
it's a big deal. Scale's a big
excuse
deal.
me, dude. Yeah, I mean, I'm trying to rush, dude, but this isn't the right image. I'm sorry, dude. This isn't the one.
I posted an image that has the accurate scale.
If you do the math works out. The sun is not a point source. It can be measured. It's like half a degree.
It is the lunar eclipse. It is
30
lunar
arc
eclipse.
minutes.
I'm sorry,
So
dude.
I was doing some math
Kinda
in the
rushed this
background here. So if you took like those searchlights that they used to put up like in front of like grand opening like movies and stuff like that, those are 5 feet in diameter. If you had one of those spotlights 600 feet away, that would be equivalent to the size of the sun from the distance of the Earth. And you could take an object. You could take a spherical ball that would be about a little more than half an inch in diameter, right, of a ball, and hold it in front of that. And even though the light rays are not perfectly parallel, you could put little toothpicks on it and it would still create the Eratosthenes effect. But then you could then take a moon that's the size of our moon and put it at the relative distance, and you would be able to generate a shadow on that moon that would be equivalent in size that you would generate in terms of the umbra and the penumbra. With all those things taken into account, the fact that the light rays aren't perfectly parallel, but Eratosthenes still, you could literally do this exact experiment. You could do it in Blender, and you would see that it would work perfectly in Blender as well.
Bro, I get what you're saying. I've seen it done. I've seen Omni do it. I've seen others do it where they scale it out, right? I'm not saying that the eclipse couldn't happen in the globe model. That's not my argument. My argument is that even in the globe model, right, the eclipse shows that the penumbra has shrunken to around 300 miles, dude. That means, right, if the shadow is shrinking, then the light is coming in, converging towards the Earth, bro. That's a problem, dude.
It's not a problem. We know the sun has a definite size. It is half a degree. If you do the math and put in the numbers, it predicts the size of the umbra and the penumbra, and it matches reality.
Next stop.
Yeah, and it requires convergent light rays.
How
Exactly,
much though?
because the
Why and
sun
how
is
quantify it?
is a physical size of half a degree as we see it.
Yeah, I know you guys think it's a nominal amount, dude. But if
It
your
is.
moon
It's
is
half a degree.
2100, I know it's half a degree when you consider the distances that your model requires. But
How much is required? How much is required?
Even a half a degree to a degree is still a significant amount when you consider the diameter of the moon, dude. The diameter of the moon is
Not. It's perfectly
2100
matches.
miles, dude. Now
The sun is much bigger.
look up the diameter of the totality of the shadow.
Yep.
Yeah, it just
And it works.
you could
The math works.
work out the math for it, right? You place an object, like I said, you could do it on a scale, right? You just all you have to do is line up a light source and then create objects that are the size of the Earth and the moon and put them at the relative distances to one another, and you will see the same relationship as far as how big a shadow it will cast. There's not some mystery
Yeah,
like this would be an easy
I
debunk that
posted,
you could easily publish and be easily replicatable if you could show
bro.
that relationship doesn't work.
Dude, I'm not even denying that shadows shrink or expand, right? We see that on Earth on a regular basis, right? But we're not saying that light is parallel though. You guys are saying that the sunlight is parallel. So when
We're
we have
saying
an example where it can't be parallel, you guys try to rationalize it with scale and say that, well, it's even though it's not perfectly parallel, the amount of convergence is nominal. It's insignificant, which is what you always
Correct.
say when we challenge your model, right? But it's not insignificant. That's a relative statement because when you consider how much the shadow has shrunken, it needs to be 2,100 miles to match the moon's diameter. Yet it's 300 miles. That's not insignificant.
It
How
is
much is it? How
insignificant
much is it?
over the
Just
course of
quantify it.
93 million miles. It works out. The
Let
math
him
works out if you do it.
let him
Well,
quantify
this is
it.
the
How
true
much
scale.
is
I finally got the bug worked out where like we're looking at the sun in this model that I'm showing live right here. And then we can zoom way the hell in to like this little line here, and that's where the Earth is. And so I don't know if you can tell, like that's fucking come on, dude.
That's
You know what I'm saying? Like this
ridiculous.
is supposed to be the true scale. And that's
it's the same
that's
as
what I'm saying. It's like
it's the same as a spotlight 600 feet away. It's basically the same as a spotlight 600 feet away. And if you had the light shining on an object that was the size of the Earth, which would be half an inch in diameter, and then you put it out to the distance of the moon, which would be like, what would that be like? It'd be several feet away from that little half-inch size Earth. You would see that the shadow that it casts onto the moon, or that the moon would cast onto the Earth, you would see that it would line up as far as the size of the shadow in terms of the percentage of the size of your moon versus how big the shadow is on the little Earth ball.
Yeah, the
ICSpin, can
people.
you turn it a little bit so we can see the sun hitting the glow in there?
Yeah.
Oh, no, wait. Turn it like the see it. Oh man, I thought you were gonna turn it the other way.
Yo, take a look at the
You can
chat
play
because I
around with it
posted
too.
some
Let
examples.
me drop this. Let me drop this again because I shared it earlier, Locksmith. I'm just gonna drop it in live stream. As I update
Okay.
it, like it'll update the build on the bottom. It's build 38 right now, so it'll update live.
But
yeah, you can play around with it. Turn on
Go.
a couple of options, and this heliocentric is like orbit view. You can change it to just the Earth view, where obviously the sun doesn't work this way and it goes around the sun, but you can just turn on orbit view and it'll be like the actual orbit, and then turn on true scale. It'll blow it up. I
nice.
just added that. But yeah, it's scale is I mean, I know it's like almost cliche at this point, like in these circles, right? But like Jake was saying, the spotlight would have to be what? How far away did you say, Jake?
A 5-foot spotlight, that's like the typical ones that they would put in front of the movie theaters, would have to be 600 feet away.
Yeah, and I've heard like if you had like a ping pong ball and you had like a skittle or something, like they would have to be like, I've heard longer than that, but 600 feet you said for a spotlight, so maybe yeah. But
Yeah,
point
bro,
is,
you,
like,
you
it's
you guys can
really
have
hard
all
to
that, dude. You can have your scale, right? But what you can't have is parallel light rays, dude. Because what
Light rays
you
are not.
need, you regardless if you say it's insignificant and nominal, right? Negligible. Regardless, light's converging, dude. It's either light's converging or it's not.
Oh, so
Well,
it has to be either
the
or. It
whole
can't.
the
It has to be
whole
one or the other, right? Yes or no? It can't be. We agree with you, but the effect generally is not.